Ravi Shankar here.
So Ravi, good afternoon.
Good afternoon.
Me here.
SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat.
Hello, Ravi Kumar. How are you? Good afternoon. Can you hear me, Dr. Ravi Kumar?
Mehta sir, we are able to hear you loud and clear. Good afternoon, Aslam here.
Good afternoon.
Hi.
Good
Hey,
afternoon.
Aslam.
Yeah, hi sir.
Hey, you look so different, Aslam. My friend.
Yes, sir. Growing old.
Age is catching up with all of us.
You know each other, sir, earlier?
Oh, yeah. Aslam, me, we go a long way back. We are the same
Excellent.
other flight
Excellent.
community. Oh, yeah. Aslam, good friend.
Okay, great.
Oh, yeah.
Good afternoon, Dr. Bala.
Yeah, hey, good afternoon.
Thank you. Thanks for joining in. Good.
Hi, Dr. Bala. How's your time away from Boeing?
I don't know. I am away from Boeing, but I still don't have enough time.
That is good for you.
Right.
Enough
So
things to keep me busy.
Very good. Very good.
Right. So people are joining in now. We have close to around 64 people joined the call. We'll just wait for one couple of more minutes. I think 1 more minute is there.
So, Aslam, you're still with HCL?
Yes, sir.
Good afternoon, Muni. Are you able to hear us?
Perfectly fine, yes. Thank you.
Okay, great. Thank you. Yeah, I think it's exactly 2 o'clock. We have around 73 people on the bridge. Shall we start or we'll wait for a minute or so?
Yeah, maybe 2 minutes after that we can have the invocation music, whatever the team has planned.
Sure.
Muni sir, how are you?
Yes, sir, fine. Thank you. How are you? Good to see you.
All good, thank you. Yeah,
Thank you, sir.
likewise.
Thank you. It's great.
Yeah, we have 86 members on the line.
Yeah, we'll see whether 2 minutes or 100, whichever comes first, we'll start.
Sure.
Maybe some of them are busy with watching budget.
Sure. If you're doing analysis discussion, budget is presented.
Correct.
Hi, good afternoon.
Good afternoon, sir.
So Muni and Dr. Ravi, let me know if we can begin.
Yeah, maybe we can begin.
We can, yeah, sure.
Yes.
Let's go ahead, Dasla.
Yeah, thank you. So, dear ladies and gentlemen, good afternoon. I am Aslam and I will be your host for today for this event. Firstly, let me thank all of you for taking time out of your busy schedule for participating in this event. We are sincerely grateful for that. I extend a very warm welcome to all of you to SAE India Aerospace Forum event, aptly titled Flying Out of Turbulence, Reimagining Aerospace Industry. I have one request to all participants. If they can go on mute, please, it will help. There is some background noise. Thank you. We are holding this event on the eve of Aero India Show 2021. We will be focusing on three main areas in this event: aircraft, drones and UAV, and airborne systems. I think I can hear an echo. If people can go on mute, it will help, please. Thank you. Okay, still mute is still I'm hearing an echo. Mr. Ilandra, if you can mute out, it will help us. Okay. Thank you. So in this event, leading industry experts will address the industry's most pressing challenges towards Atmanirbhar Abhiyan in aerospace. I think I can still hear it.
No, I think, Captain, I think maybe you have got two devices at your place which are talking.
No, I am just on laptop. I have not switched on any other device.
Sure. Then there is a background noise.
Yes.
Can you go on?
Okay, thank you so much. Okay, I can still see here. Okay, I think we can start with the invocation. I will call upon Mr. Longon and I will go on mute.
We don't hear anything, gentlemen. Dr. Ravi, we don't hear.
I think
Unless you.
Yeah. Aslam? Aslam, are you able to hear us? Okay. I think Aslam has a problem, looks like. So welcome. This is Ravi here. Welcome, everybody. I'll take over before Aslam joins in.
I have joined, Ravi.
Okay, great, Aslam. Take over.
Yeah, because of the mute problem, I thought, let me just check. Okay. All right. Thank you for that beautiful rendition. We next have Mr. Javaji Muniratnam to give the welcome speech. I will just introduce him. Mr. Muniratnam is an aeronautical engineer with a postgraduate diploma in management. He has over Okay. I will introduce Mr. Muniratnam. He is an aeronautical engineer with a postgraduate diploma in management. He has over 30 years of experience in engineering space, right from project management to operational management and establishment of strong organizations. He is the founder CEO of Javaji M Consulting, which focuses on cross-border activities in aerospace and defense. He began his professional career in HAL and moved to engineering services industry in early 90s. He has worked on many international projects in Holland, USA, Germany, etc. He has moved from technical roles, customer interface, and business development to manage the pan-European operations on engineering services. He was the country head for DSQ Germany. During his tenure in Germany, he has opened accounts with global players like Airbus, EADS, BMW, Audi, IBM, etc. After returning to India in 2002, he has joined Godrej Group company to head the European accounts and later promoted to head the engineering services business unit. He has steered the unit to grow from 35 to 350 member team in a short span of time. In 2007, he joined A-System India, which was a 100% subsidiary of A-System Group as its Indian CEO. A-System Group was a global engineering consulting company with a revenue of $1 billion and 10,000 plus employees. He has brought in considerable transformation in its operation by introducing various business verticals, implemented best practices like ISMS, AS9100, Semilac certification, etc. And he has expanded the operation to different geographies in India. His professional activities are: he is the outgoing chairman of SAE India Aerospace Forum. He is currently the chairman of APSSDC COE for A&D. He is the honorary board member of Imperial Society of Innovative Engineers. He was the past chairman of SAE India Bangalore section. He was the past management committee member of Indo-American Chamber of Commerce. He was the founder president of Infinite Association of Indian IT companies in Germany. He is a recipient of Dr. KCG Excellence Award for Distinguished Alumnus from Hindustan Group of Institutions. Ladies and gentlemen, I present Mr. Muniratnam for giving the welcome speech. Over to you, sir.
Yes, correct.
You may have to mute yourself.
Very good afternoon, ladies and gentlemen. Once again, I welcome you all for this interesting event, aptly titled as Reimagining Defense Aerospace Industry. I know it's an important day for two things. One is the budget. Second thing is our aero show is going to begin tomorrow. So on this occasion, we thought that we should have this event. Okay. I just would like to briefly give a little bit of information about SAE in general for the benefit of some other participants who may not be that familiar with SAE and its activities. SAE was started about 100 years back by Henry Ford and Wright brothers. And over the years, it has grown leaps and bounds. And today it has got about 138 members across the globe. And very interestingly, there are a lot of standards committee, etc. in this. And most importantly, SAE plays a very active role and has got a deep impact in aerospace. Many of us think that it's only automotive. It is actually very deep into aerospace activities. SAE has over 22,000 standards. And these standards are formulated and updated on a regular basis by industry leaders like you. And there are various technical committees. I'm happy to share that our technical committee chair for this session, Dr. GVV Ravi Kumar, is also chair for one such technical committee called G31. It's a great honor and privilege for SAE India in general. This is about global aerospace activities. And coming to SAE India, SAE India has been in existence since 24 years. And in SAE, of course, we look after three activities: aerospace, automotive, and off-highway. And aerospace activity is started as a board about 11 years back, headed by Dr. Bala Bharadwaj, who's on this conference now. He was former managing director for Boeing India Technical Center here. So under his leadership, we went through various activities across SAE, both automotive, aerospace, and off-highway. And I take this opportunity to briefly give you an overview of what we have been doing for aerospace fraternity in the last couple of years. I'll just share a small presentation to you.
Yes, Mr. Mani, we are able to see.
Yeah, thank you. So we had a series of events. Just to begin with, we started our aerospace board in 2010 when Kuala came to India within a couple of years of his arrival in India. So we had this session called Intelligent Asset Management. Again, he was the international president for SAE. We had value management, Jeff Hoffman from NASA, along with the Institute. Then National Aerospace Conference Exposition at 2012 at MIT Chennai. Then new vistas of Indian aerospace at Indo Chamber of Commerce. Then one of the most important things is conducted by SAE International Board in India in Bangalore and Hyderabad. Then along with PMA again, we had another event called Propel High with Project, but important topic for practicing engineers. The whole integrated vehicle health management workshop, as well as technical for the first time in India happened in 2014, of course under the leadership of Dr. Bala. Then Make in India transformation driver for aerospace and defense in 2015. Then Blue Ribbon CXO Conclave, specifically focused on aerospace activity by aerospace leaders. Then celebrated 5th anniversary of formation of aerospace December 2015. Then we had another a couple of other events, multi-city events during the visit of board of directors from SAE International. Then we also participated in the Skill India initiative, working with KPM. Then during the air show in aerospace, then, now, and future, very we had international participants as well. And the systems engineering and public management conference, very successfully participated. Then digital revolution, aerospace and defense industry, 2019. Very recently, we had it's a precursor to the Aerocon 2020. During our conference, very successful event. We had 600 plus participants, amazing speakers, excellent panel discussions we had, and aerospace manufacturing business and technology imperatives jointly held with Tamil Nadu Aerospace Industry Association. With this, I think we have been to connect with aerospace industry leaders and professional members to exchange the knowledge, as well as to ensure that we all kind of solve our common problems. We had, of course, I don't want to dwell into that. We had interesting discussions during the last conference on February. So as a practice, we have this event air shows. So once again, I wish you a wonderful time for this conference. I take this opportunity to thank each and every forum leaders and the SAE and other aerospace colleagues from the industry for having given us an excellent support during my entire journey for the aerospace forum activities. I've come a long way, and I'm sure it will go further even better. And I'd like to welcome, I take this opportunity to welcome Mr. Ravi Shankar Mysore, very able and experienced leader from the aerospace industry, and I'm sure he will take it forward to greater heights. Once again, thank you all. Wish you a good. Thank you, Captain Aslam.
Thank you, sir. Thank you for that welcome address and for covering all the details of the activities of SAE India Aerospace Forum. Thank you so much, sir. It is now my pleasure to introduce the next speaker, that is Dr. Tessie Thomas, a distinguished scientist and Director General Aeronautical Systems. Dr. Tessie Thomas, Distinguished Scientist, Director General Aeronautical Systems, obtained her BTech in Electrical Engineering from Government Engineering College, Trichur, Calicut University in 1985, and Master of Engineering in Guided Missiles from Institute of Armament Technology, Pune in 1986, and then subsequently PhD in Missile Guidance from Jawaharlal Nehru Technology University, Hyderabad in 2014. She obtained her MBA in Operations Management from Indira Gandhi National Open University, New Delhi in 2007. She has been a recipient of many prestigious awards of national as well as international. Just the last three, if I read out, has been awarded the Distinguished Women Scientist Award in 2016 by Andhra Pradesh Science Congress, Andhra Pradesh Academy of Science, Outstanding Women Achiever Award in the field of science and technology by Women in Science and Engineering India, the Missile Bhushan Samman by Vigyan Parishad Prayag, Jodhpur in November 2019. Ladies and gentlemen, it's my pleasure to call upon Dr. Tessie Thomas, Distinguished Scientist, Director General, Aeronautical Systems, to give her inaugural and special address to this forum. Madam, over to you.
Respected Sri Javaji Muniratnam, Sri Damodaran Subramaniam, Dr. Bala Bharadwaj, Sri K. Venkataraj, and Sri K. D. Sheshadri, invited speakers, and all distinguished members present here, a very good evening to all. I am indeed very happy to be here among SAEINDIA Aerospace Forum for the inaugural session of the conference on theme Flying Out of Turbulence, Reimaging Defense Aerospace Industry. I take this opportunity to thank the organizers of this conference and be a part of this webinar. The journey of aerospace industry evolved from the year 1903 when Wright brothers demonstrated for the first time an aeroplane flying in a powered and sustained manner for 12 seconds above the Kill Devil Hills. Within 2 years, in 1905, Society of Automotive Engineers International USA was founded by Wright brothers and Ford Henry. During 1920s, cantilevered wings, enclosed fuselage and cowlings gave aerodynamic shape to the aircrafts. By mid 1930s, metal became the material of choice in aircraft construction, and the new types of components, suppliers and the industrial aircraft manufacturers came into existence. Many advances in aircraft's design took place during this period, addressed the comfort, efficiency and safety of the air travel, like cabin pressurization, retractable landing gear, better instrumentation and navigational devices around the airports. World War II set the agenda for the aircraft industry around the world, and more importantly, new types of vehicles joined the skies. With the new technologies, a massive restructuring of the industries happened, and the airframe industries shifted from manufacturing to research to technology and to specific startup firms. It also modified the airframes for greater speeds and altitudes with the introduction of jet engines. Intercontinental ballistic missile programs started way back in 1954 as winning weapons to replace massive numbers of aircrafts, which became an all-time high-tech industrial approach worldwide and revolutionized the spacecraft and the rockets that lifted into the orbits. Internationalization reshaped aerospace by helping industries across countries to establish spacecraft overflying the national borders within seconds with the newly developed navigation systems and airspace protocols, and played a major role in aviation. By 1990s, more than 30 nations started developing capacity to manufacture aircraft and its components for military and communication needs of the developing nations, and set the pace for technological advancements in the economy. Air transportation has undoubtedly been one of the finest benefits of technology to the modern world. The ease and speed of international travel has brought the world closer. The current world population is estimated to be the order of 7.8 billion, and on an average about 9 billion passengers fly around the world annually prior to the COVID pandemic. Remarkable blend of technology and craftsmanship, airline operations around the globe have achieved something extraordinary. Aerospace and defense are the two core sectors that are crucial for strengthening the defense of a nation. Fast-paced technological changes are taking place in these fields, and both public and private sectors are making efforts for indigenous development of latest equipments and weapon systems. There are encouraging signs of the aerospace industry emerging as a major contributor to our self-reliance and export business. Honorable Prime Minister's call for self-reliance and Atmanirbhar Bharat aims to transform India into a global design and manufacturing hub. Manufacturing of the military hardware is identified as one of the most important segments. The defense industrial corridors, Tamil Nadu and Uttar Pradesh, are expected to meet the requirements of Indian armed forces and create an ecosystem within the country for effective indigenous defense production to reduce the dependence on foreign sources for military hardware. ISRO, Indian Armed Forces and DRDO should serve as the engine of growth for our indigenous aerospace industry, and research and innovation should become the fuel for growth for any industry, and then the country can perform well above the mark of achievements. DRDO started industry involvement in early 80s, mostly under the build to print. Within 2 to 3 decades of nurturing and participation in DRDO projects, industries could get hands-on experience on defense production, like design, simulation, prototype manufacturing, testing, quality control, performance evaluation, user trials, and certification requirements for military equipments. Post successful trials, the limited series production of systems were carried out within the industry, and this established the engineering for production process. DRDO enables these industries to get exposed to the technology, processes, and quality standards for both defense and aerospace. By involving the Indian industries from development stage itself, many of the private sector industries have moved up the value chain from build to print to build to specification to build to design to build to requirements. Today, some of the industries are capable of being lead system integrators and can manufacture technologically advanced products of world class. India undoubtedly has the potential to become one of the key players on the international stage in the competitive aerospace industry, which is the domain of highly developed countries for decades together. India continues to be one of the top defense spending countries in the world. With the increased liberalization of defense procurement procedures and ban of 101 different types of weapons, systems and ammunitions, and with the focus on Make in India program, it gives significant impetus to the domestic industry towards achieving self-reliance in the defense sector. DRDO has listed 108 systems and subsystems that will help the Indian industry to design, develop and strengthen the local production of defense ecosystem. This initiative will pave the way for the Indian aerospace and defense industry to develop many new technologies towards building an Atmanirbhar Bharat. From being a supplier of raw materials, components and subsystems, Indian companies are now progressing to become partners in manufacturing and integration of complete equipment and systems. Many licenses have been granted, which is reflective of the current manufacturing capabilities of the Indian industries. Sectors with dominant private participation have quickly moved into building capacity and adapted new technologies and started delivering to international standards of quality. With more and more DRDO developed systems getting user acceptance, the capability to build complex indigenous systems and platforms have been established in the country. Some of the new initiatives to enhance the DRDO industry partnership are in the areas of aeronautics, missiles, propulsion, rockets, gas turbine engines, long range radars, advanced control systems, advanced materials and composites. Defense Technology Development Fund was given by DRDO towards startups and MSMEs to support them to undertake high risk development tasks. DRDO established Research and Innovation Center at IIT Chennai as a research park for advanced research in high technology areas involving academia, research fellows, student community, industries and scientists. It functions as incubation center and allows private sector industries to absorb these technologies effectively. By participating in DRDO projects, today there are 700 plus Indian private sector industries all over India who are capable of manufacturing high technology systems, subsystems and components in the field of missiles, avionics, electronic warfare, naval systems, compact vehicles and aerospace. There are a large number of niche areas where the nation's young talents can be leveraged to attain a competitive position in developing next generation technologies. Niche areas for the next generation technologies are nanotechnology, composite materials and advanced aerospace materials, advanced avionics and electronic miniaturization, stealth technology, cyber warfare and cyber security, automation, robotics and artificial intelligence, advanced manufacturing technology, additive manufacturing and 3D printing and so on. Continued focus by the MOD on greater private sector participation, especially for the startups and MSMEs with defense corridors, have enhanced the role of private industries for defense equipments. Year 2021, industries should focus on improving the areas of propulsion and aero engines, additive manufacturing and lightweight aerospace components. Maintenance, repair and operations, the MRO of new aviation technology has to be adapted with simulation and predictive maintenance. Autonomous flight systems will be the future of aerospace industry, like UDAN scheme for the regional connectivity and autonomous drones for both civil and military applications. Innovations in jet engine design and production have been the main source of aircraft efficiency improvements for the decades together, but today engineers are giving more attention to the airframe reshaping to reduce aerodynamic drag. Artificial intelligence techniques such as machine learning are being introduced into the new areas of aerospace with the potential to make huge strides in aircraft design and manufacturing. COVID-19 is one of the biggest challenges aerospace and defense companies have ever been faced. While the impact of pandemic is not evenly spread across the industry, all organizations will need to adapt to a post-COVID world. Digital technology is transforming everything from customer experience to engineering and manufacturing. Digital technology has the potential to transform every aspect of the aerospace and defense value chain. To emerge stronger, companies must adopt on digital transformation. Smart technologies and robotics will enable the next generation of products and services. A vibrant aerospace industry is an important contributor to the nation's economy and security. Its continued growth and outcome will provide magnetism for the nation's engineering and entrepreneur talents of today and for the next generation. As a facilitator of such talent, the aerospace industry should steer the nation on the cutting edge technologies and innovations, aiding towards economic progress, missions of national security, civil space agencies, and the defense sector. To conclude, aerospace and defense leaders need to ensure that their organizational culture allows for an easy assimilation of these new technologies. The aerospace and defense industries need to deal with these profound changes and steer towards digital transformation, leverage smart technologies, and balance the drive for efficiency for a digital future. We need to adopt intelligent solutions powered by artificial intelligence. We need to reimagine resilience by enabling talents and revolutionize digital transformation to increase the speed of strategic operation of reviving the whole aerospace and defense industry. I am sure today in SAEINDIA Aerospace Forum, many eminent experts will be addressing the industry challenges towards Atmanirbhar in defense aerospace. I wish this conference a very vibrant interaction and set a roadmap for the future transformations. Thank you and Jai Hind.
Thank you, madam, for your impressive and in-depth perspective on Atmanirbhar Bharat in the aerospace sector. I will now proceed to the next, we will now proceed to the technical sections. I will invite Dr. Ravi Kumar GVV. Let me introduce Dr. Ravi Kumar. Dr. Ravi Kumar is an Associate Vice President and Head Advanced Engineering Group of Engineering Services, Infosys. He has led numerous innovation and applied research projects over the past 20 years. His areas of expertise include mechanical structures and systems, knowledge-based engineering, composites, artificial intelligence, robotics, autonomous systems, AR, VR, and Industry 4.0. He was actively involved in the development of commercial product like Autolay, CATS Composites, which was a spin-off of the Indian LCA program. He was also involved in NIA Knowledge, which is a knowledge-based engineering platform, and KRTI 4.0, an operational excellence framework. He is a member of HM1 and G31 technical committees and chair of G31 technical committees of SAE India International, and he has contributed to aerospace development, standard development. Dr. Ravi Kumar has published over 50 technical papers, 4 patents, 2 have been granted and 2 are filed. He has a PhD and a master's in technology in applied mechanics from IIT Delhi and a BE honors from BITS Pilani, India. Over to you, sir, for the technical session.
Thank you, Asla. Are you able to hear me? Okay. First of all, welcome everybody, the entire SAE India fraternity and all the people who are joining this particular session. It's great honor and pleasure to talk to you. So what I'm going to do in next couple of minutes is essentially to give a kind of perspective about the overall program, the thought process in putting up this particular program. So as you know, this particular event has been envisioned at the backdrop of the corona pandemic. So we have put the overall theme as flying out of turbulence, reimagining aerospace industry. More specifically for the Indian aerospace industry, we have structured this entire program into 3 broad categories. One is the aircrafts, that includes both commercial as well as the fighter aircraft programs. Then the drones and unmanned air vehicles and the airborne systems. So these are the 3 areas that we have picked up as the overall theme for this particular event. And let me introduce the technical sessions that we have planned today. Essentially, we are going to have two broad tracks. These tracks include the commercial and fighter aircrafts in the track 1. Then the second track will give a kind of overview about the drones and airborne systems. In each of these tracks, we have keynote addresses from eminent people and also a panel discussion which gives a kind of perspective about the challenges and opportunities in that particular track. That's how we envision. Then even in the drones and airbornes, it is a similar. We have two, one special address and one keynote address and one panel discussion. Okay. We are going to have charts for each of these tracks. Now I will introduce the first chair of the track 1 for the commercial and fighter aircrafts. He is the chair of this particular panel is Dr. Ganga Reddy. Ganga Reddy is General Manager, Head of Aerospace and Defense Mechanical Division with HCL Technologies and has over 23 years of experience in aerospace industry. He holds a degree in mechanical engineering, post-graduation and PhD in mechanical engineering. He has worked extensively in the aeromechanics testing and validation. He has more than 12 publications in various peer-reviewed journals and conferences and filed 2 patents. I will now pass it on to this particular track chair, Dr. Ganga Reddy. Over to you, Dr. Ganga Reddy.
Thank you, Dr. Ravi, for that introduction. Good afternoon, ladies and gentlemen. It's my privilege and honor to chair the first track of today's conference, which is centered around the theme, India's commercial and fighter aircrafts. As a part of this, we have galaxy of eminent personalities who will be addressing this forum from Indian aircraft industries and research centers. They will be delivering keynote addresses and deliberating important topics as a part of panel discussion. In the first keynote speech today, we are honored to have Dr. Girish Deyadare, who will be speaking to us on Indian defense aircraft programs, current status and way forward. A warm welcome to you, sir. A brief introduction about Dr. Girish Deyadare is, he is Distinguished Scientist, Program Director for Combat Aircraft and Director of Aeronautical Development Agency in Bangalore. He graduated with BTech degree in Electrical Engineering and MTech degree in Control and Instrumentation from IIT Bombay in 1984 and 1986 respectively. He earned his PhD in Control Theory from University of Waterloo in Canada in 1990. He started his career in DRDO as a scientist in Center for Artificial Intelligence and Robotics, Bangalore. Later, joined the Aeronautical Development Agency. He is involved in design and development of flight control systems for the Indian light combat aircraft using both classical and modern control synthesis techniques. He has many rewards and recognition to his credit. A few of them are, he was awarded with the Distinguished Alumnus Award from IIT Bombay in 2016, DRDO Award for Performance Excellence in 2013, INAE Young Engineers Award for the year 1996, DRDO Technological Award for the year 1994. He has more than 40 publications in peer-reviewed international journals and conferences. Now I request Dr. Girish to deliver the keynote address. Over to you, Dr. Girish.
Good afternoon. It is an honor to speak in the SAEINDIA forum. Even though it is for automotive engineers, today we are using many of the SAE standards for aerospace development, and it is a very important forum for us. I'll talk today about Indian combat aircraft programs. These are exciting times for Indian combat aircraft programs and the current status and the way forward. I'll start right from the beginning. Way back in the 80s, there were some very bold decisions taken by our leaders, especially Dr. Kalam, who decided that when we are making a new combat aircraft in the country, indigenously, we will go for futuristic technologies, not even latest. At that time, there were futuristic technologies, things like unstable aerodynamics, where I've written there as time to double as low as 200 milliseconds. What this means is if you get a perturbation to this aircraft, within 200 milliseconds, this perturbation doubles. So in effect, in a second, it can become 32 times. This is the kind of instability this aircraft was planned with, which it has today, which gives it enormous maneuverability. But at the same time, it creates a problem because such an unstable aircraft cannot be controlled by a human being. It requires a flight control system, a fly-by-wire flight control system, to control this aircraft and make it maneuverable. Other decisions like going for composite structures, 90% of the weighted area of this aircraft is composites. And at that time, none of these technologies were really available in the country, or we were not even it was not even in the horizon. But an important decision was that if we had failed to apply the latest technologies then, we know LCA development took time. It took more than 20 years. But today, this aircraft is state of the art. And the reason is these decisions. LCA was supposed to replace MiG-21, but we didn't make a MiG-21. We made something much, much better, which is why today this aircraft, as you can see, is very contemporary and will form an important part of the Indian Air Force. When we started in 1980s, ADA was formed in about 1984. At that time, there was hardly any aerospace technology in the country. It was nascent. We had the HF-24 Marut in 1961, and after that, somehow the development didn't happen in the aerospace sector. It was mostly licensed production. And in 84, when it was decided to kickstart the aerospace ecosystem in the country, there was a huge gulf. And all these technologies have to be developed from scratch. So in 2001, when LCA flew for the first time, this was the technology demonstrator. Not only did this aircraft fly, but also all these fourth generation technologies, which I mentioned in the previous slide, which actually took off and started getting proven in the air. Today, Tejas, as you are well aware, is a well-proven platform, and as will happen in a few days, we will have the 83 aircraft contract being signed. We have already completed more than 5,000 flight test sorties on this aircraft. These are sorties done by us designers, not what the squadron is flying. So each of them is monitored and we look at the data, and each sortie something new is being done. So we have done 5,000 of this without any incident. And IOC of this aircraft was achieved in 2013, FOC in 2019. The first squadron at Sulur was formed in 2016, and the second squadron very recently in May of last year. This aircraft, a major milestone for this aircraft was when it participated in the Bahrain Air Show. This was the first time the aircraft was demonstrated outside the country. These were the prototype aircrafts which we fly. This was done in 2016. And even more importantly, in 2019, the squadron went to Malaysia for the Malaysian Air Show, which was another landmark event. The aircraft has participated in all the IF exercises, Gagan Shakti, Vayu Shakti, and so on, and come out very credited. Aircraft trials have been conducted in hot weather trials right up to 48.5 degrees centigrades, in very cold weather trials, minus 15 degrees centigrade at Leh, including starting up the aircraft there. All these didn't happen smoothly. There were a lot of problems, there were a lot of iterations over the years, and this took time. But today, this is completely mastered. The aircraft has very good accuracies with various kinds of bombs, dumb as well as smart. It can fire close combat missiles, beyond visual range missiles, and it's a multi-role aircraft. In addition, we have also done air-to-air refueling. The capability has been demonstrated with more than 2,700 kgs of fuel, which were transferred in the air. The production plan of LCA, as most of you might be aware, the first 20 are in the IOC configuration, 16 are already delivered. The trainer deliveries will happen soon. The second 20 are in the FOC configuration. These are basically differences in some capabilities. And 3 aircrafts are already been delivered, and the rest will happen very soon. And the pace has accelerated. And as you are aware, the 83 aircraft in Mark 1A configuration, the contract will be finalized very shortly. And these will be completed by 28-29. Now, HAL has also picked up the production, because making a licensed aircraft and making your own indigenous aircraft, there's a big difference. because here you have to learn everything, learn the production processes also on your own. And this has now stabilized, and HAL has accelerated with 2 and now 3 lines. So the Mark 1 aircraft is an improvement on the FOC aircraft with additions like AAS radar, RWR, external SPJ pod, and so on. But the external geometry of the aircraft remains the same. So that's why the production will go through very smoothly. Now, what is indigenous in this aircraft? When we started way back in the 80s and when TD1 flew in 2001, the objective there was to make an aircraft and prove all these technologies. Now, to prove these technologies, we wanted to use proven components, proven equipments, which were mostly imported. We didn't want to develop the equipments and the aircraft at the same time. So these were mostly imported, but subsequently, many of them have been indigenized. And today, about 62% of the equipment are indigenous, which I have mentioned a few there. Most importantly, the digital flight control computer, which is the heart of the aircraft, and the air data computer as well, and the avionics computers. Everything is indigenous. So out of 344 LRUs that Tejas has, 181 are already indigenized. And right now, through MSMEs, we are going forward, and more than 68 LRUs are in the process of indigenization. But what people forget when they say that Tejas has an imported engine, it has an imported radar. The most important thing is what is indigenous is the design capability, which is not obviously seen as material elements in the aircraft. For example, the critical 4th generation technologies, which cannot be taken from another country. It has to be developed in the country. Aerodynamic design of such a high performance aircraft, fly-by-wire flight control, avionics, composite structures, computer controlled electrical and mechanical systems, flight testing. This some people forget because this class of aircraft, as I said, is very unstable, and we have to go to the limits of its capabilities. So when you go there, it becomes quite risky because you can lose such an aircraft if you over exceed the limits. So flight testing of such an aircraft to take it right to its limits is again a technology which has been mastered. Over the years, it took time how to test this aircraft, say till about 26 degrees angle of attack. The test facilities that are required for these technologies have all been developed. So today, we have the whole base available for designing any future indigenous aircraft in this country. So whether it is, as I'll talk later, whether it is the Mark II version of the LCA, the AMCA, or the naval version. So as I mentioned, what's coming up, this was the current status that we are today. So we have the complete base setup, and we have the LCA, which is proven most of the technologies and successfully inducted in the Air Force. So what's coming up next is LCA was a replacement for MiG-21. Now it was decided, let's go for the next class of aircraft, which is the Mirage 2000, which is a larger aircraft. It has much more capabilities. LCA is a light and a small aircraft, so it has a limited amount of carriage of weapons and so on. It is not a strike aircraft. It's basically an air defense aircraft. Most of the time, it remains within the territories of the country or just goes immediately across. Whereas if you want to go deeper, you need a bigger aircraft with more fuel and more weapon carrying capability. And this is what is the Mark II, which has been conceptualized. It has enhanced capabilities like AAS radar, IRST, MAWS, internal electronic warfare suite, and so on. But more importantly, it has a much higher range and endurance. It has a higher weapon carrying capability, and it can carry heavy standoff weapons, like what you saw in the Balakot, the Scalp Crystal Maze Spice 2000. So this is a replacement for the Mirage class of aircraft. This aircraft, the configuration is frozen. System architecture has been completed. Detailed design is in a very advanced stage, and rollout of this aircraft is planned in mid-2022 and the first flight by 2023. Now, why these aggressive schedules is because this is a 4.5 generation aircraft, similar class as LCA. So the technologies are similar, which are all ready and available. That is why we can confidently say that this aircraft can roll out by 22 and fly in 23. LCA Mark II evolution was also an interesting story, and this shows the maturity of our design ecosystem, including the user. On the left is the Mark 1 and Mark 1A. And the Mark 2 initially was planned just by putting a more powerful engine, just changing the engine from GE 404 to 414. That was the initial concept. However, the users, Indian Air Force sat with us and designed this aircraft along with ADA to get something that they want in terms of what exactly their requirements are. And that is what has evolved as the final configuration in 2018. This is with a canard and it's much longer and can carry a payload almost twice that of LCA Mark 1. Incidentally, in LCA development, we had a very interesting involvement of the user, the Indian Air Force. All the flight testing was done by Indian Air Force. So the pilots and engineers, flight test engineers, used to come from Indian Air Force. They used to come for periods of 2 years and 3 years. And we have had almost 25 pilots, test pilots, who have been involved in the development. Now, these are pilots from all classes of aircraft, whether it's the Russian aircraft, the Western aircraft, the naval aircraft, and so on. And these were the top guns, and they have learned what is involved in designing this class of aircraft along with us. In fact, the Chief of Air Staff today was the head of our flight test for some time, for 3 years, in 2002, I guess. And even the vice chiefs, the deputy chiefs have been ex-pilots who have gone through the process. So they understand what is involved in the design. What can you achieve with this class of aircraft is what they understand. And that is how this Mark II has been designed along with the Indian Air Force sitting with us and conceptual. The next one, which is an ambitious step taken, because now we have the technology, we have the capability, we have to develop a little bit more, and that is the 5th generation AMCA. In fact, the Air Force came out in 2018 and said that we want to pursue this path rather than import a 5th generation aircraft, FGFA. So this is a twin engine stealth aircraft, and this is shaped for stealth. As you can see, the shape is such that there is a edge matching, which makes the RCS, the radar cross section, very low. It has an internal weapon base, so it carries its weapons internally in the belly. So that again reduces the radar cross section because the weapons can affect the radar reflection. It has a diverterless supersonic intake, which is a new development which happened over the last year to year and a half in the country. This will be the first aircraft in the country having this kind of intake. It is a serpentine intake, again for stealth, so that the engine face is not visible from the front. And of course, it has a whole lot of radar absorbing structures and materials incorporated. Now, this development actually started in 2010 with the feasibility studies along with the Air Force. And this has matured, and today the configuration is frozen and the preliminary design is also completed late last year. Through COVID, we worked through and finished off the preliminary design. The rollout of this aircraft is planned in 2024 and the first flight in 2025. Now, initially, this aircraft, the first few squadrons will be made with an existing engine, which is already available off the shelf. But importantly, the future squadrons will be made with an advanced engine, which will be made indigenously. This is the decision taken by the government at the highest level. And this will be an indigenous engine, probably with a partnership with some foreign OEMs. But it will be an indigenous engine. And this will be the main indigenous engine in the country for this class of aircraft. Also, the production of this aircraft, the manufacturing and production of AMCA, is planned through an SPV, which will have HAL and private agencies. So this is currently in the process, and very soon we should have an SPV formed for development of AMCA. The AMCA specs in short, so it is a medium weight, about 25-ton aircraft, and it has a very low RCS. This aircraft can operate both in a stealth and a non-stealth mode. In the stealth mode, as you can see on the top, all the weapons are carried in the belly internally, and it has a very low RCS. But so this will be used in the initial stages of war. But once you have got air superiority, this aircraft can be used as a normal non-stealth aircraft, which can carry a huge range of weapons. And in fact, in the internal weapon bay, it can carry extra fuel, which gives it a huge range and capability. So this was about the Air Force aircraft development. Now, parallelly, in about 2003, once TD-1 had flown in 2001, Navy expressed a desire to have an indigenous aircraft in the country. Now, this is quite a challenging task because over and above what LCA can do in the air, now it has to operate from an aircraft carrier, which is just 200 meters long. On the ground, you can take up to 1 kilometer to take off. Whereas on the ship, you have to take off in 200 meters. From a ski jump, it's a ramp. And the landing also has to happen in 90 meters using the ship's arresting wire. So this was a huge challenge. And the decelerations experienced here are of the order of 4.5 Gs. And the sink rates can reach up to 7.1 meter per second, huge. So it was decided that we would make a technology demonstrator by taking an LCA aircraft and making a prototype with strengthened landing gear, strengthened structures, and various other modifications, even to make it approach at low speeds to be able to catch the wire on the deck. So for this, we built 2 naval prototypes, and more importantly, a shore-based test facility was created at Goa. Now, this is a replica of the ship on the ground in Goa, which has the whole arresting mechanism and also has the ski jump ramp. As you can see on the left is the ski jump ramp in Goa, and on the right is the arresting mechanism, the wires. Most of it is underneath all the hydraulics and so on, so you can't see much on top, but this is a replica of the ship deck. And this was set up, and tremendous amount of testing happened in this facility, because going to a ship for the first time is very critical, because if there is any mishap, you may damage the ship itself, which is a huge asset. So more than 400 high sink rate landings were done in SBTF, progressively increasing the sink rates to make sure that you are able to do it perfectly. And taxiing engagements, that is just taxiing down at high speed and catching the wire and making sure that all the structure was able to take the loads and so on. So in the SBTF, we achieved the first ski jump in December 2014 and the first arrested landing in 2019 September. So once this was proven, we went to the carrier, and in January 2020, as you are aware, the LCA landed on the INS Vikramaditya for the first time. But what was remarkable was, in 5 days, it could do 18 cycles of takeoffs and landing on the carrier. And this was because of the tremendous amount of preparation that was done on the shore-based test facility over the past 4 to 5 years. So with these technologies being proven, now the Indian Navy was confident that we could make a naval combat aircraft in the country. And that's when the decision was taken to go ahead for a twin-engine deck-based fighter for the Indian Navy. So the twin-engine deck-based fighter, the TED-BF as it's so called, is a medium-weight 26-ton class aircraft. It is planned as a replacement for the MiG-29Ks, which are operated on our carriers today. It is a stow-bar variant, that is a ski jump takeoff but arrested recovery class of aircraft. Compared to this is the catapult launch aircraft, which also we are capable of making, but we need a carrier with a catapult. So the second phase of this aircraft could be with a catapult system when we have the ISE-2 available. But currently it is planned for operation from the INS Vikramaditya and the ISE-1 carrier, which the Indian Navy operates. And this is planned for first flight by 2026. The concept design is complete. In fact, in Aero India, you will find a model of the first concept design, which generally meets all the requirements that Navy wants. We are also doing some advanced technologies. In fact, AMCA, which is a 5th generation, is going to actually incorporate 6th generation technologies when it comes to AMCA Mark II. And one of these is optionally manned cockpit. So we are testing out automatic takeoff and landing on the LCA aircraft with the pilot in the cockpit as an emergency backup in case of any surprises. So this activity is currently on. It should be completed by end of this year. Another system we are trying out is the flash air data system. This also improves stealth considerably. And for this, we have taken a drop tank, fuel tank of LCA, and equipped it with all the electronics and the flush sensors, which are required for the air rate. And this will also be flown on LCA, like a drop tank, but at the same time doing the complete flush air data system technology. So this also should happen in the very near future. So the plan for combat aircraft development in a nutshell is shown here. We have the Mark 1 Tejas in process. It will be followed by Mark 1A, which will be signed, and Mark 1A is a delta improvement over Mark 1. So there is no major new technology, so it should happen very smoothly. The Air Force Mark 2, which is a bigger version of LCA, with using the same technologies. The AMCA Mark 1, which is using the existing engine, but with stealth technologies, which are now in a very advanced stage of development. The TED-BF, the naval twin engine aircraft, and finally AMCA Mark 2, which is our own indigenous engine, which is a more powerful engine in the AMCA platform. So the goal is to have complete self-sufficiency for combat aircraft by 2035. Now, when ADAWA started in 1984, the plan was not only to make an aircraft, but to develop an aerospace ecosystem in the country. And to a large extent, this has been achieved. There are more than 300 work centers today working for design of aircraft along with ADA. These include DRDO labs, academic institutions, private institutions, CSIR labs, and so on. And over and above this, HAL is engaged with more than 400 to 500 industries for making LCA. I mean, the parts are outsourced, the assemblies are outsourced, and they are put together. HAL is the integrator. So there's a huge ecosystem that has been set up in the country for aerospace, and we are poised to leap now. Thank you.
Thank you, sir. Thank you, Dr. Girish, for delivering excellent insights into Indian defense aircraft programs, its current status and way forward as well. It was indeed inspirational to hear the rapid strides right from 4th generation fighter aircraft to 5th generation and way forward for 6th generation fighter aircraft, which is our AMCA Mark 2, which we are making in fighter aircraft space. I'm sure that it will augur well towards the Atmanirbhar Abhiyan. Thank you once again, sir, for your wonderful keynote address. Now, we all know India is the third largest aviation market in domestic traffic, which has shown consistent growth of 20 to 25% during pre-COVID years. Let us hear from our next keynote speaker about how we are gearing up to address the ever-increasing demand of aircrafts for domestic travel. Now, I take this opportunity to introduce our next keynote speaker, Mr. Jitendra Jadhav, Director of NAL. A warm welcome to you, sir. Mr. Jitendra Jadhav, Director NAL, who will be addressing us on Indian commercial aircraft programs, current status and way forward. Mr. Jadhav is the Director of CSIR, National Aerospace Laboratories, Bangalore. He obtained his Bachelor of Engineering in Electronics from University of Pune and MS from Computer Engineering Department of Defense Institute of Advanced Technology, Pune again. He has more than 29 years of experience in design and development of military systems of Army, Navy, Air Force, industrial and railway application. He has designed, developed and commercialized major systems like fire control systems for tanks, airborne digital optronic pedestal for Nishant, optical fire control systems for Navy mission, and display computer and weapon control systems for LCA Tejas. Under the able leadership of Jadhav, as Director of CSIR NAL, the laboratory is making important contribution towards the furthering the Make in India initiative by Government of India. Sri Jadhav has won many awards and laurels for his recognition for his significant contributions from ADA and DRDO. He has published more than 20 papers in national and international journals of repute. During his short tenure at CSIR NAL, the laboratory has received the Technology Innovation Award and TechnoFest Award in the year 2016. A warm welcome to Mr. Jitendra Jadhav, sir, again. Now I request Jadhav sir to deliver the keynote address.
So good afternoon to everybody here, all distinguished guests and all my colleagues as well as SAE senior people and organizers. It's my privilege to have to give a keynote address on this SAE India Aerospace Forum at Aero India 2021. So I will be talking to next 20 minutes on Indian civil aircraft programs. That is what my topic has been. And I will be taking you through how the National Aerospace Laboratories is the only organization in India who has taken design, development, and certification activities of civil programs. And I will be take you through the complete roadmap and the current status of the programs. So if you see CSR, I thought that I must say you what is CSR-NL because this is a forum which people may not be knowing what is CSR, National Aerospace Laboratory. So we are basically started in late 60s and we are the first blowdown of wind tunnel happened in 1967. Thereafter, we have taken up a two-seater Hansa project for training aircraft. And then we started working on light combat aircraft project, key technologies like composites and fly-by-wire. Then we made our own aircraft called Saras and flown in early 2000. And then we have now three verticals. Basically, one is applied research, second is the technology facilities, and third one is the civil aviation. Click. Civil aviation. We have a material applied research in materials, thermal barrier coating, stealth materials, so on. And in the civil aviation, we have a roadmap to make a new next generation Hansa NG for flying trainer, and also a 19-seater commuter aircraft, regional transport aircraft, and by 2030 we will be going on to the hybrid aircrafts as well as high altitude long endurance aircrafts. Next. We have an annual budget of about 337 crores and we have 978 employees and we are certified for ASO 9100D. Next. So this is our core strength. We are basically 10 divisions where we have aerospace material and surface engineering, which is very core strength of us. We have a structural design and analysis, very strong group. About the national facilities, we have a wind tunnel testing, fatigue testing, acoustic test. We have a very strong group of failure analysis and accident investigation. In fact, we are number one in the country to do all accident investigation and all the military aircraft as well as nowadays civil aircraft accident investigation also at our place. Aerospace instrumentation, electronics, composites, and flight mechanics and control. So this is our core competence of CSR. We have these unique facilities. We have 4 wind tunnels, fatigue test facility, acoustic test facility, electromagnetics and all. So whatever facility is required to take up any aircraft program, they are all available at one place in the country. Next. Now I will take you through the programs for civil aviation. Next. So in civil aviation, there are basically 5 types of aircraft. One is flying trainer, which is very much required for the flying clubs. They start from 2 to 4 seater. There are commuter aircrafts up to 19 seater, which is one of the Beechcraft and Dornier and all that class. There are regional transport aircraft which come from 30 to 100 seater. A narrow body aircraft for 130 to 180 seats and wide body aircrafts from 180 seat onwards up to 380 seats. So this is the category of the civil transport aircrafts. You take India, the major thrust has been given from 2016 by government to promote a regional air connectivity. And if you see the right side, there are about 4 clusters. I have made complete India into 4 clusters. One is Western cluster, Northern cluster, Eastern and South. And as an example, if you see a northern sector with Delhi, I connected Ambala, Gwalior and all Chandigarh. That very close aircraft which were very small vicinity. And nowadays, using narrow body aircrafts for such a routes is not very economical. So they are all within 500 kilometer. So to come to promote all these villages or tier 1 cities, I can say, or tier 2 cities, tier 3 cities, getting connected to the various things for the economical growth as well as the industrialization. It is a need of today to give a air connectivity, which is the fastest and the safest as on today. So what we have found is there is a high demand to make commuter aircrafts as well as regional transport aircraft, because narrow body and wide body already two international partners are there, and India cannot take a big step to take this development. So we have taken a development of trainer, commuter and regional transport aircraft, which are much needed for India to for next 10 years. Next. So this is the today's scenario in the commuter aircraft and the regional transport aircraft. As commuter aircrafts, there are, I told, there is a Beechcraft, Dornier and LET from Czechoslovakia, Czech Republic. And there is a Bombardier, ATR and IL-114 from Russia. All these technologies are almost 2.5 decades old. As on today, they are very costly to acquire because there is no technology upgradation has happened, though ATR 72 has come up with the recent upgradation. They are very expensive to operate because their spares are costly. Many design houses or OEMs has stopped the business now, and they can operate only from well-equipped airfields and basically very high fuel consumption and direct operating cost. Next. So Indian operators demand we have studied, and what they need today is the flying trainers which can give a good endurance and a cheap cost. And they also need a commuter and regional transport aircraft for operating at high altitude routes with pressurized cabins. They are looking for a 19-seat, up to 19-seat commuter transport aircraft for connecting tier 1, 2, 3 cities for less than 300 kilometer haul. They are also looking for 70 to 90 seat regional transport category aircraft connecting same cities wherever airfields are operable for less than 500 kilometer haul. They need a high cruise speeds, they need a reduction in ownership cost, they need a reduction in fuel burn. But important thing is they want the ability to land on ill-equipped fields and operate from high altitude airfields, which is a challenge. All these aircrafts which are available at 2.5 decade technologies are very difficult to operate from high altitude airfields and small runways, and is definitely environmental friendly. Next. So there is a demand of about 70 to 100 flying trainers and 120 to 150 numbers of commuter aircraft and about more than 200 numbers of regional transport aircraft. Next. So I will just take you through trainer aircraft. So we had a Hansa 3 which was developed in 1985 as I told. But now NL has taken up the development to upgrade that as the next generation. In this basically we are going ahead with a new aerodynamic optimization and more comfort to the pilot. But basic thing is it is going to be a IFR compliance, 6 hours endurance, 900 kilometer range, and cost will be about 50 to 60% lesser than the competitors. So this project is revived in 2016, and we are in the we will be making first flight by March 2021, and also certification activities will start subsequently. We have already more than 15 numbers of LOI issued from various flying clubs. So it will be the one of the biggest execution model because our cost is almost 50% cheaper than any international aircrafts. And you see the complete glass cockpit and the hosiery which is shown at the bottom and the aircraft at the top. This aircraft is already in prototyping and it's likely to fly shortly. Next. So these are the basic unique improvements we have done. We have gone to glass cockpit. We made a bubble canopy with the single this thing. We have electrical operated flight, and we also went for the steering wheel and fuel efficient new sports engine we have put, which is of digital control and all this IFR compliance, lightning protection, endurance and range. Next. Then the second requirement, as you seen, that for less than 300-kilometer thing, we need an aircraft of 19-seater. Press video will run. Okay. So we had a SARAS program and we revived it in 2017, and the upgraded prototype on the top is made a maiden flight in 24th January 2018, and the bottom you just click. At the bottom we have a, this has been demonstrated in Aero India 2019, and we almost completed 26 flights of this. That was the reason behind it was to take up a next generation Mark II aircraft and make it more useful for the commutation purpose. Next. So we, after this flight test, we sat on to drawing board and seen what are the problems in PT1N, and there is a substantial drag reduction required. There is the improved controllability. It should have a lightweight, and the cabin should be from 14 to 19 seater, and it should have a flight controls, autopilot, and all that thing. So we were gone for a, if you see the top, it's a pusher configuration. So we gone for a tractor configuration now, Mark II. Next. And we have made the improvements like optimization of flaps, shaping, wing, fuselage fairing, nacelle. All these improvements has been done to meet the requirements. Next. And these are the basic technologies. There is a digital controlled turboprop has been put. Autopilot is there. Complete modular avionics will be there. A structural health monitoring, green lead structure, lean ground structure. We will be putting advanced mechanical system, and we will be achieving this through advanced materials, coating, and high drag and low drag aerodynamic fixes with composite airframe and structural health monitoring. Next. So this is the picture of the cockpit, how it will look. Next. So this aircraft will have a quick conversion into three basic modes. One is the troop transport mode, which is at left side, where 19-seat thing with lavatory, or 18-seat with lavatory and 19 with without lavatory. It can be configured as a VIP aircraft, where we can take about 10-seat VIPs. You see a very comfortable layout of carrying about 10-seat VIPs, and it can also quickly change over to role of Casavec cabin, where we can carry about 8 stretchers at one go. Next. So this is basically a complete indigenous thing. We will be using about 35% composite in this aircraft, and the airframe is completely indigenized. Landing gear is also indigenized. We are using the indigenous high performance dual power PC based avionics computer, which is our own Swadeshi design. Also hydraulics, CCS, cockpit, cabin, lot of indigenization except power plant has been planned in this aircraft. Next. So this is the performance of this aircraft, which I was telling that airlines is looking for an aircraft which can be useful for a high altitude airfield. So top numbers are basically the range and payload, but the bottom table is very important because such an aircraft making and availability is not so easy from the imported source. So the Kulu airfield, we will be taking almost 14 packs because that airfield is very small and it is at altitude of 1500 meters and all. Shimla will be taking full almost 15 pack. Tangkong, which is at almost 2000 kilometer altitude, 2000 2 kilometer altitude. There also we will be taking 19 packs. Kargil will be taking 15 packs, and Leh, which is 3000 meter altitude, will be taking almost at ISA 8 packs and 15 packs at this thing. So this is how the aircraft has been configured to give a maximum payload or passenger load factor to the airlines at the airfields where today no other aircraft, if you buy, will operate. That is how the aircraft has been done. So ultimately, we are telling that this aircraft will have a multi-role quick change in configuration. It can operate from hot and high airfields. It will have a cockpit ergonomics, very important. 3D to 90D percentile pilots will be comfortable there. There will be autopilot and avionics for Cat 2 landing, because all such a class aircraft are Cat 1 landing, but we will be giving Cat 2 landing, a pressurized cabin. We will give low SFC and also IRNS and Gagan compatibility. We got an initial induction order from IF, and HL is our partner. Production will start from 2025. Next. So this is the comparison of this aircraft will all contemporary. So they cannot operate because their cabin is unpressurized. So they cannot operate at high altitude. So only competitive aircraft is Beechcraft, but that is stopped, and partially it would have operated because its takeoff weight is very high. We are managing with very low takeoff weight and also many other aerodynamic fixtures. So this will be the aircraft which is the perfect vehicle to meet the commuter requirement all over the country, right from the northern part of the country to the southern part of the country and east to west. Wherever you go, this aircraft, all fields are, it will be operable. That is how this aircraft, which will be certified by 2024 and it will be produced at HL Kanpur from 2025. Next. We also taken that these two were a sanctioned project and they are having a fixed timeline. We also taken up the design of 70 to 90 seater aircraft, where it is a 4 abreast design, which you are seeing right side with 30-inch pitch. And there also we are planning to use technologies which has been used for 19-seater aircraft, which will be scale up in this aircraft, and some factors of this altitude and all that has been given here. But the major thing here also is all-weather operation, high and hot airfield and unequipped airfield. So this ATR 72 and Bombardier, which are there, which is having a decade-old technology, they cannot today operate from unequipped airfield. So there will be a special landing gear which we are done it in Saras. That part of technology will be used, and also fly-by-wire control technology will be used to get this fuel consumption and all lower, which is not available in such a class of aircraft as on today. Next. So we have completed our market survey and airlines and drawing specification, all these things has been done. And we are now at the DPR submission stage. The right side you are seeing the complete layout of 4 abreast seat, and all the CFD studies, MDO studies, wind tunnel test has been completed, and we are awaiting the approval from the government. Once government is approved, within 70 months, this aircraft will come for the flying. Next. So what we learned is basically by 2021, there will be a Hansa NG, which is a trainer aircraft, which is very important from the cost point of view from the flying trainers. And that will be in production with Indian partner Mesco Aerospace, which we already signed the project, and it will be start production from 2021. In 2024, we will be, and that aircraft is likely to fly in a couple of weeks. In 2024, we will be finishing Saras Mark II, which is 19-seater aircraft. HL Kanpur is the design, production agency, and the production will be starting at HL Kanpur from 2025. And then from 8 years, if government sanctions the project, we will be flying 70 to 90-seater aircraft, hopefully by 2029. So this is the complete roadmap of the civil aircrafts, which will be towards the Atmanirbhar Bharat. Next. So what we'll achieve? there is a substantial FE saving in tune of thousands of crores to the government. There will be employment generation of more than 50,000 people in the next 8 years' time. There will be a trust to promote several MSMEs, skill development, technology development, infrastructure and ecosystem development, and entry into the international civil market. So this will be the unique example of Atmanirbhar Bharat for India and export. Thank you very much.
Thank you, Mr. Jadhav, sir, for your wonderful insights into Indian commercial aircraft, starting from how are we planning to develop flying trainers, which is a 4-seater, commuter aircraft, which is 19-seater, which is essential for towards Udan scheme, which excellent scheme from Government of India to connect the Tier 1 and Tier 2 cities, and also regional jets, which will be around 70 to 90 seaters. Once again, thank you very much on behalf of SAE India for your wonderful keynote address. That we will, there is one announcement which I have to make to all the participants because of the prior commitment. Both Dr. Girish and then Mr. Jadhav sir, they could not take the live questions. I have noted down the questions. I saw some of them in the chat window. I have noted down. By evening, I'll get the answers to the respective participants who has posed that question. So moving on to your next topic on the agenda. So till now we have listened to Indian defense and commercial aircraft programs, current status and way forward. Now we move on to interesting panel discussion, challenges and opportunities for industries to support Indian aircraft programs. The panel discussion will also provide a roadmap and message to aerospace community in post-COVID era. This panel will be moderated by Dr. Kota Harinarayana sir and will have 5 eminent panel members from aircraft OEMs, Tier 1 and technological service company. I take this opportunity to give a brief introduction. The reason I'm telling brief introduction, all 6 of them are stalwarts. To introduce them, it will take a longer time. Keeping the time in mind, I just said it is a brief introduction. So Dr. Kota Harinarayana sir graduated from Banaras Hindu University in Mechanical Engineering, postgraduate in Aero Engineering at IISc Bangalore, PhD at IIT Bombay, and holds a bachelor's degree in law. As program director and chief designer of LCA, he successfully directed the project leading to flight testing and clearance for limited series production. Thanks to his efforts, India succeeded in developing a state-of-the-art high-technology fighter aircraft of world class. He is the fellow Aeronautical Society of India, former president of the same society, National Academy of Sciences, and Indian National Academy of Engineering. He received Distinguished Alumnus Award from Indian Institute of Science and from IIT Bombay. He was awarded National Aeronautics Prize and FIE Foundation Award. He was honored with Padma Shri by Government of India in 2002. Indian National Academy of Engineering conferred upon him the Lifetime Contribution Award in Engineering for the year 2006. Apart from this, he held several positions with the academics, and he continues to mentor both the aircraft industry as well as the academics. A warm welcome to you, sir. We are privileged to have you here. Joining Dr. Kota sir will be in the panel will be Mr. Kishore Jayaraman. Mr. Kishore Jayaraman is president for Rolls-Royce India and South Asia. Since taking over the role 8 years ago, Kishore has been instrumental in driving strategic focus and significant expansion across the Rolls-Royce defense, civil aerospace, and power systems business. Prior to joining Rolls-Royce, Kishore held diverse leadership roles across markets at GE for 23 years, and his last assignment was president and CEO of GE Energy South Asia. He holds a MS in Mechanical Engineering and also an MBA. A warm welcome to you, the panel, sir. Joining our panel is one more eminent leader from industry, Mr. Tejasvi. He is the director of sales, Boeing Commercial Airplanes, as the senior in-country executive, leading sales engagement for airline customers such as Air India Express, Vistara, and SpaceJet. Tej has been with Boeing for over 11 years and has held various positions in customer and tech support. strategy and business development, and sales and marketing. Tej is qualified to certify multiple Boeing airplane models. Prior to Boeing, Tej spent 10 years as an aircraft engineer with Cathay Pacific, Saudi Arabian Airlines, and Air France. Tej holds a MBA from Warwick Business School. A warm welcome to you, sir, to the panel. Another eminent person who will be joining us in the panel discussion is Mr. Satish Shastri, who has over 22 plus years of experience in avionics industry. He holds a degree in electronics and communication and also a postgraduate diploma in business management from the Indian Institute of Management, IIM Bangalore. Satish joined Collins Aerospace in 2008 from Honeywell when Collins started its India Design Center, that is IDC, at Hyderabad, and was one among the initial leaders who played a key role in establishing the IDC as a Center for Technology and Innovation to support global businesses. He currently leads the military and commercial avionics engineering portfolios for India and support business development activities in the APAC region. A warm welcome to you as well, sir. So we have another eminent speaker joining our panel discussion, Mr. Mantha Venkatramana. Presently is working as a Chief Executive Officer at Explio Technologies India Private Limited, taking care of the 2 delivery centers in Bangalore and Chennai. The major aerospace engineering projects being delivered from India operations are related to structural design and analysis, avionics development, and system integration. He possesses more than 33 years of experience in aerospace engineering domain, brings in strategic direction and change leadership through his diversified experience. He has been an active flight test engineer and fixed wing aircraft with Indian Air Force during his first 18 years of his career. He had held several leadership positions with Quest, HCL Technologies, and Axis Cadis prior to the current role. A warm welcome to you, sir. And another eminent speaker from industry who will be joining our panel will be Mr. Krishna Mohan, who is a graduate in mechanical engineering and masters in aerospace systems engineering. In 2008, Mr. Mohan joined Moog India Technology Center, Bangalore, as the head of design department. As a part of leadership team, he took ownership to build the capable design, stress, product engineering teams at Moog India Technology Center, with focus on done right, first time, on time, every time. Along with established SMART goals for his team, could successfully execute engineering support activities for Boeing 787, A350 commercial aircraft programs. Under his leadership, Moog India Technology Center team could successfully establish the world-class qualification test lab meeting DO 160 standards and FAA guidelines. His team successfully completed the qualification test on Boeing 787, A350 and E910 flight hardware, and currently few test programs are still in progress at the facility. Prior to the current role, he had worked for TISCO and ADA. A warm welcome to you, sir. Now, I request Kota Harinarayana, sir, to take over the panel discussion and deliberate and moderate the panel discussion, sir.
Let me welcome all the panelists. Today's topic is challenges and opportunities for industry support to Indian aircraft program. A very, very important topic of great relevance to the country's progress. And I'm very happy, very distinguished panelists are here. Kishore Jayaraman from Rolls-Royce, Tejasvi Narasimhan from Boeing, then our friend Satish Shastri from Collins Aerospace, Mohan Krishna from Moog India, and Mantha Venkatraman from Explio Technologies. Very, very varied experience, varied background. And I think we are going through a very, very critical phase now, world over, in the field of aviation. Let's look at India because the topic is of India. India became the 3rd largest domestic aviation market in 2019. And we were predicting by 2022, we will become the 3rd largest civil aviation market, including international. But now, with the COVID-19, it is predicted by 2024 we will become. That is, there is a delay of 2 years. That is the kind of a scenario. And there is a tremendous impact on the operators, civil aviation, and all cascading effect on other industries related to civil aviation. For example, Indigo, which has been always a profit-making company, this quarter from October, November, December, they declared a loss of 627 crores. And this is the, if you see the same period last year, they made 490 crores and the revenue fell down by more than 50%. So that is the kind of impact you can see that has happened. But good news is that the IMF just declared just 2 days back that India's growth in 2021 will be 11.5%, the highest in the world. Okay, we are back to double-digit growth that is occurring, and next year also fairly good, much higher than rest of the world that is happening. And the industrial activity has more or less come to the normal. Economy has come to a very good stage. Earlier we were thinking that a very huge contraction of GDP, but it looks to be that it will be around 8% or so. That is the kind of scenario where we are. And FDI investment, I don't have the latest figures, but first quarter, if you look at it, we had $2.7 billion as the investment came to aviation, directly into the air transportation field. That is what is there. So a lot of positive things are happening. Now let us look at the development programs in India. As far as civil aviation is concerned, at NAL, National Aerospace Laboratories, 2 programs have been approved and the work is going on at fast pace. One is a new generation 2-seater trainer aircraft. Almost prototype is ready, and I do believe in a month or 2 it's going to fly. And it is designed, taken into account the customer's requirement and all, and an industry partner is already in place. There is another 19-seater commuter aircraft, pressurized aircraft, that is also has been approved. And the design project definition phase work has been completed. Detailed design is going on. They have been talking to various partners and all. Here is an opportunity where we need to look at how industry can participate. Third is not so much known, but the old HS748, which HAL manufactured under license, even now the large number of these aircrafts are in operation with the Indian Air Force, and they have taken up a program of re-engine and new avionics and a few other system changes, whereby they are trying to see they can position it for 40 to 60 seater aircraft, especially to operate at higher altitudes where there is a demand for that for Indian operators. The other thing which we have been discussing for a long time is the 90-seater regional turboprop aircraft. India is the largest market for this one, and almost 500 aircrafts are required. So India should take the lead. There is an in-principle clearance from the government, and a lot of push is now being given. And that is one aircraft program where a lot of industry support has to participate, in addition to what I have told there. So broadly, this is the kind of scenario where we are in developmental programs. And come to the military aircraft programs, we are all happy that at last the 83 Tejas aircraft clearance has come from the cabinet, and that itself will give us a lot of boost. And the Tejas LCA Mark II, which is a heavier aircraft, much bigger aircraft, it can carry almost double the payload. The design is in very advanced stage and manufacturing has just started. We are expecting about 2 to 3 years the aircraft will come out, roll out and start flying. And there is a 5th generation fighter called AMCA, which is the 5th generation stealth fighter. That also a lot of design development and technology development activities going on. It demands a lot of new technology, new equipment, new things. And there is another development program called unmanned combat aircraft, which is being pursued by our friends at ADE. And this again is a 6th generation kind of a fighter program, and a lot of new technology, new equipment, new ideas, new thinking has to come in, and that is where industry has to participate in a much bigger way. If you look at the whole thing, while aircraft programs are on, and some of the equipment, certainly avionics, we have developed, the engine still is a major challenge. I think that's where we wanted our friend Jayaraman to speak first and see how to handle this fellow. And also, while we have done fair amount of work in general systems and flight controls, avionics, but a lot more need to be done. And that is where I thought we need to look at it. And manufacturing support, I think a lot of thanks to Boeing, Airbus, and all other companies, quite a bit of infrastructure and tier 2, tier 3 level of development has occurred, infrastructure has been created. But I would like to hear from all of you. So with this background, I thought with that kind of a scenario, India being a major, what you call, center as a marketing civil aviation developmental program, and in military, a major thing, major initiative being taken up here. And you also must have heard from Chairman HAL, there is a lot of inquiries from many countries in the world for the light combat aircraft cages. They want whether that can be exported. And the government of India is keen to see that it could be exported. Okay, so these are the kind of opportunities, not just 83 and all, lot more is on the plate. That is where we are. With this background now, could I now request our friend, our opening batsman Kishore Jayaraman, to speak for about 5 minutes and tell us, give us the motive power so that the panel can move forward.
Thank you very much, Dr. Harinarayana. It's a pleasure and a privilege to be here with you all. Being the opening batsman, the pressure is always there because the ball is new and the pace is going to be tremendous. But I will try to clear, I'll try to handle it as much as I can. As you all know, Rolls-Royce is in 3 businesses. We are in the civil aerospace, defense aerospace, and defense other spaces like the army tanks, the frigates, destroyers, aircraft carriers. So we are also in the power systems business, which also does a lot of business with our defense team here. Now, when I look at aerospace in particular, when you take civil aerospace, it's a country that has a lot of narrow-body aircraft today. So we've been flying a lot of these aircrafts and growing over the last 15 years. I remember 15 years back when I used to come to India, there used to be Jet Airways and a couple of airlines, along with Air India, all which used to be Indian Airlines, and very minimal aircraft. But today, when you look at it, you have more than 600 aircraft, more than 1,000 countries. You have a tremendous amount. So we have a tremendous amount of engines on the ground. And I think in civil aerospace, there's a lot of opportunities in the MRO segment. And as we look at the MRO segment, it also has an opportunity to not only service all the existing aircraft, but also create opportunities that as the Indian civil aviation market grows, I think there will be opportunities for the wide-body aircraft. So we can not only service our own wide-body aircraft from the Indian airlines, but we'll also be able to service other airlines that are coming over from overseas. So I think it's a tremendous opportunity that exists, and I think the market is just brilliant. We need to be focused on the infrastructure that needs to happen there. So if we continue to focus on the infrastructure, continue to focus on MRO initiatives, I think that sector, civil aviation in particular, has a lot of headroom to grow. Now, when we go to defense, I think Rolls-Royce is in all 3 segments: in transport aircraft, in combat aircraft, and in trainer aircraft. So in India, we participate in all these 3. We got the Jaguars, we have the Hawk trainers, we have the Hercules, So I think all these aircraft have the potential. They're all being serviced in India today. We do it in collaboration with HAL. And, and some of these aircrafts still have room to have their own MROs here in India. But as the space grows, as the number of engines continue to grow, I think the localization initiatives will only increase more and more. Spare parts being produced locally, repairs and services being done locally. So the opportunities are plenty in the space. Why are these opportunities plenty? Primary reason is that the geopolitics is tremendous. As we all realize, since 2020, since the COVID pandemic, countries have gone into their little silos. And also India has seen a lot of skirmishes in the borders. Things that we didn't expect in the past have started happening. So India needs to protect itself. And aerospace is definitely a power to be reckoned with when it comes to protecting the country. So I do believe that the future is going to have a lot of potential in terms of civil aviation and in defense for aerospace. But it's also a question of how do we position India in that space. And I think when you look at the Make in India, it is about designing it somewhere in the world and maybe manufacturing it in India. But if you really want to make it in India, then I think we have to design it in India. And I think then we have an opportunity to drive the supply chain. Then we have an opportunity to do the manufacturing here. And then we have the opportunity to do the services here. So to me, the future of how we create aircrafts is going to be in co-creation and partnerships with countries, with companies. And in that space, Rolls-Royce has been working very closely with a lot of government organizations and with a lot of private players, trying to figure out how we can do engine development in India. We have to co-create these products. And I think once we co-create, the IP is owned. Once IP is owned, it becomes a lot easier to control the rest of the processes. So I think in defense for our country, for our own security purposes, eventually the engine development will happen. Normally an engine between 7 to 10 years. So if we start the initiative today, it will take about 7 to 10 years, and after which we'll have a flying engine. But that requires a lot of funding up front, and that requires a lot of technology partners. So I think these initiatives have to be promoted and pushed for very quickly, because once that happens, we will be in a real strong position to control our own destinies. Having said this, I think it is. We can talk about it more. If you have any questions, we can answer it. But at the end of the day, the future is extremely strong. It's extremely bright in terms of aerospace in India. It is the emerging sector, and it will continue to be emerging for quite some period to come. And I think being positioned in the space is great for all of us. Thank you very much for this opportunity. Happy to answer any questions.
I just want you to take a half a minute to talk about where Rolls-Royce is taking initiative along with Siemens on the electric propulsion or hybrid propulsion. That's what I thought. Would you like to say anything about that?
No, at this point in time, okay, very happy to do that. But I think if you look at our future programs, I think one of the spaces that we are very particular in is the electric, not only just a hybrid electric, but a full electric aircraft. And so to that effect, we are working with many companies around the world. And I think we will eventually come out with a product in that space. It's still got a long way to go. I do believe that eventually that's where every country in the world will go to in order to achieve a net zero economy. And India is very particular about going to the net zero economy. So I'm very bullish that India will actually be able other places. We do have the talent in India, so we will leverage the talent here in India. We will help design these aircrafts globally, and then hopefully I should see them flying in India before too long.
Okay, thank you. Thank you for your comments. Now we have our OEM friend going, Tejasvi Narasimhan. Could I request Tejasvi, how do you look at it? How do you think India, the industry should position itself for the new civil programs and also military programs?
Thank you, Dr. Harinarayana. I think I will start off. We have some slides where we do our commercial market outlook, and we have released in the last year during the pandemic. We have seen how the market has evolved. So if I can take a couple of minutes and show the slides, that would be really good.
Sure. Okay.
Aviation, we have seen, has been resilient, and we can see that in 9/11 we had the dip, and we saw that same dip again during the 2008-2009 financial crisis. But this dip has been tremendous. Though you can see the trend line, the actual traffic RPKs has been pretty much consistent with the trend line, but we see that in the last 10 years, it has been a tremendous growth for commercial aviation. And we hope, in the few years, once the pandemic is over and the recovery happens, I think this trend line will catch up again. One good green patch is India's domestic market recovery is right now leading the world. On May 25th, when we opened the domestic market, we had about, in a 737 or a 320, we had about, 45, 50 passengers per aircraft, which has about 185 to 189 seater. Right now, we are about 125 to 130 seats, passengers filling up the aircraft. What we are seeing is this domestic market is recovering faster than North America and many parts of Europe. We are also seeing that new versions of what we call freighter, where it is a passenger freighter, where you have started carrying, cargo on the seats of the airplane, cargo under the seats of the airplane in the hat racks. And Boeing is sending out multi-operator messages and helping each of these airlines to carry cargo, be delivering vaccine, medical supplies, essential items across India and across the world. Also, the restrictions which have been removed on e-commerce and everything else is fueling. India, as I always mention, has still got an opportunity to have one big-time cargo operator. We still operate with SpiceJet Express, Spice Express, and Blue Dart Cargo. I think we still have place for one large operator, just like the FedExes and UPSs of the world. Boeing has been helping through the pandemic to the questions that's been asked by the airline operators to operate, keep the airplanes clean, using of chemical solutions, using of technologies throughout the pandemic, so that all the airplanes are in flight mode. The airplanes are maintained either when they were parked, they were maintained in short-term storage. We have very dedicated maintenance planning documents which help these airplanes to be ready to fly anytime they unground the airplanes. In India, what we are seeing is the significant passenger demand. So if you see 2019 to 2020 levels, we were down about by 55% in the domestic market. We are going to see this recovery only in the second half of 2022. I think later in 2021 and early 2022 is when we'll see an uptick of the domestic passenger market. International will take some time. It's going to be about 2023 when the international will remain. Overall demand will only double by 2030. This decade, the initial decade, might be a little slow. But the cargo has got tremendous potential, as I already mentioned. We have a 6.3% growth per year in the domestic India trade. These two airlines have done extremely well. And talking to the CEO of Spice Express, he just noted that they were about 100 in the Delhi airport area in terms of carrying cargo. In 2020 and 2021, right now, Spice Express has become the #1 cargo carrier, and they proudly carry the 737NG full freighter now. So how is Boeing helping all these airlines, airports, and also passenger confidence? What we did during the pandemic was when we saw that the over 17,000 airplanes being parked, passengers being hesitant to walk into the airports. If you don't have passengers walking into the airports and into the airplanes, how is that we will fill those airplanes? So Boeing worked with all other OEMs, be it Airbus, Embraer. We have worked with the academia. We have worked with Harvard Medical School and everybody else. We have started the Confident Travel Initiative. We are working across the regulators, the government agencies, airports, airlines, and also including the medical academia. We are starting with home, departure airport, airplane, in-flight, and arrival airport. I'll take you through immediately on this, especially on the airplane. There's a lot of question whether the airplane air is clean or not. The airplane air, about every 2-3 minutes, the airplane airflow is changed. That's how clean the aircraft airflow is. But if you look at a house, if you have a closed door, closed house, it's about 5 to 6 times when the airflow changes in a house. The HEPA filters which we are using in the airplane has about 99.9%. They do the cleaning of all the particles there. And these HEPA filters have got very varied timelines during which they have to be replaced by the airline staff. And also the cabin airflow flows from the riser ducts from the top, goes down to the below. So there is no harm of any. What we have also done is we have used academia and medical to see how the airflow happens using some inert viruses which are not very conducive to the human beings, and we have used that, and we have seen the data-driven optimization within this. We have been working with all the stakeholders, and we continue to do it so that we bring the confidence back in the passengers so that they can confidently walk into the airports and into the aircraft and do their business. Again, India is going to play an important part in the Asia-Pacific region and also South Asia. Predominantly, India is going to be the growth region out here. And as Dr. Kota Harinarayan just mentioned, India is the 3rd largest domestic market in the world. And we'll see that domestic market is going to become India at some point of the time in the South Asia is going to take up the whole space. And just over 1% shift over the 23 million passengers who travel by rail. Even if 1% shifts to the air, you will see that that just rapidly doubles the aviation market. I think that's going to happen as soon as the confidence travels and then the whole thing starts moving in the right pace. This is just going to happen, and then there's going to be a complete burst. And what we see is how the Indian, what are the key trends to watch in India? And key contributors will be the economic growth, rapid growing middle class and infrastructure investments. But the headwinds will be financial health. I think all the airlines will need to take care of the financial health. The currency, most of the airplanes are traded in dollars. I think they need to take care of the currency hedging. The yield has to be, you can have capacity, but if you do not have yield, then you're going to be really fuel price. I think India, the ATF, aviation turbine fuel, is one of the costliest in the world. We were just doing the calculation the other day, and we saw that the taxes upticks this India's, it tilts to the right by about 50%. I think we can have very fuel efficient engines and airplanes, but I think if we are going to be increasing the price of ATF, I think we need to take care of those taxes. And also the foreign competition, and as Jayaraman said about the geopolitical conflict. And these are some of the headwinds that we need to take care of. What is Boeing doing it? And this is a predominant question, what the OEM is going to take part in. Over a decade back, we had about 2-digit people, Boeing badged employees. We have now about 3,000 Boeing badged employees working throughout India. We outsource, we source about more than $1 billion in India. We have over 160 plus suppliers, tier 1, tier 2, tier 3. We have a joint venture with Apache, with Tata's in Hyderabad, where Apache fuselages are being manufactured. We are also working with IITs, Indian Institute of Science, and other R&D partners, and also working on upskilling programs. This is the upskill program which Dr. Kota Harinaran mentioned about, and we are actively working with many.
Good. Thank you.
Thanks.
Thank you very much. Thank you very much, Tej. Now I would go to Satish Shastri or Collins Aerospace. Shastri to comment on how they can support the programs by local manufacturing, local development and all. Okay, Shastri.
Thank you, Dr. Kota Harinaran, sir. It's a pleasure to be here. Like you mentioned, Collins is not new name in the aerospace industry. Coming to India specifically, Collins India, we have around 4,000 engineers. We have footprint both in terms of engineering R&D design center, and we have our manufacturing facility. Specific to engineering, we have our engineering design centers in Hyderabad and Bangalore cities. We have around 3,000 engineers contributing to various global programs. We serve actually all 6 business verticals under Collins Aerospace, which is avionics, mechanical systems, interiors, and aerostructures, power and controls, and mission systems. Mission systems is focused on pure defense. Just coming back to India specifically, specific to avionics, I know you talked about avionics and flight controls. Just to give you a little background about our journey, we started our journey in avionics in 2008. But in the last 12 years, I think we have grown rapidly, not just in terms of engineering strength, but also in terms of design capabilities. We have our engineers contributing to flight management systems, display applications, flight controls, communication, navigation, synthetic vision, all suite of avionics products. And then I can proudly say we have established great capabilities in developing safety critical applications compliant to DO 178, B, C, all the way from level A to level E, right? So that's the pedigree in terms of what we have established here. Coming back to what you started off, sir, with specific to civil programs, let me put it this way. I think we as Collins India, right, I think we are part of many global programs. And invariably what happens is, we have significant contribution being made by India team. Sometimes depending on the product and the domain, we may have anywhere from sometimes 70 to 80% of the content would be done here. But what happens is there is always some portion of the core technology which is still done by our global teams. So The opportunity that I see here is, I think, we have established great capability in software and developing safety critical applications. But how we can contribute is to Indian aircraft programs is, we should explore joint development opportunities where, the Indian PSUs who have very deep experience in platforms, they can design the platform. Whereas, we as an industry partner can bring our exposure that we have in developing, DO 178B compliant applications. And, I think that's the sort of, collaboration, that's the sort of, environment that we need to create where both of us can jointly work on a project. The reason why I'm saying is generally, in India, no one company has the pedigree to sort of do end-to-end, let's say, fly-by-wire flight controls, right? There is always, we have participated in global programs, but, when it comes to hardware and other aspects of, like, for example, control loss, right? I mean, that's something that we don't have exposure to today. But for the control loss, rest all applications we have had great exposure to. Now, that's where I think NIL and, they have developed all these control laws, but to make a, civil certified flight control systems, we can bring that expertise as to what it takes to, develop a civil certified application. So I think that's one place where I can see, we can clearly harness and play to our strengths and, collaborate. That's one. And I think there are many examples of this that in Europe and US where, you define the scope very clearly, form a team, and give them a finite time period. And I think, it's definitely possible. And then the other aspect of every time we have, tried to sort of collaborate is I think we look for, lowest sort of vendor, L1 comes into picture. And from a Collins perspective, what we feel is, sometimes L1 alone will not give you the best solution or, the value for money, right? I think we should also look at the pedigree of the organization, the IPs, the innovation disclosures that the organization has in that domain or in that space. If you start giving weightage to that, I think that's sort of the pedigree that you're looking for a partner who can make your program successful, not just the cost alone. I think those are the couple of things that I think we should keep in mind when we want to engage, with the industry. On the military side, it's again, there is tremendous opportunity on the military side. The reason why I'm saying that is, if the military platforms were to be open system architecture, right? What could happen is, again, our, Indian agencies have very deep knowledge of the platform. They can make ruggedized hardware, right? And the industry, which has a lot of capability in software, can collaborate. For example, in US, there is this consortium called FACE, right? It stands for Future Airborne Capability Environment. This is a consortium that's formed by US government agencies. There are industry partners like Collins Aerospace, Lockheed Martin, Boeing is part of this consortium. And they have developed these open standards, right, for the industry partners to collaborate. And, what this enables is a vendor-free, neutral platform for any vendor to develop applications which are compliant to those open standards, right? Then what happens is you have the platform being developed by Indian agencies. There could be multiple industry partners who are developing the software applications which can be hosted on that. And, Collins Aerospace was one of is a pioneer in that because we developed the first FACE compliant application in US for the US military platform, and India engineering team played a significant role in that. So this is another opportunity that I see where we can all come together, right? We can collaborate with Indian agencies, academia can be part of this consortium. We can all come together, define open standard that would work for us, right? And we can define what it should be. And once that is done, then, industry, academia, all of us can collaborate. That creates that ecosystem for us to sort of come together and collaborate. And even for the Indian agencies, you don't have to depend on one vendor, right? I mean, once you have gone for this open standard, open system architecture, you will have multiple vendors, who can compete. It's a healthy competition that we are creating. So I would say, I think, let's look at this, how to collaborate with the industry in a very holistic way. Understand, the strengths of each player, and and also some challenges, right? That's where I'm saying, let's do a joint development where the risk part of that gets addressed a little bit, right? And once there are a lot of unknowns when you work on an avionics program, any particular domain. It's complex. It's so complex that every time you execute a program, there are a lot of unknowns that you run into, and that's where I think if you sort of do a joint development sort of a program, I think that's the way to go from my perspective.
Thank you, Satish. Very nice suggestions. Could I request Krishna, my good friend?
Yeah, thank you, Dr. Kota. I will quickly share Moog in India and our support to Indian aircraft programs. We supply more than 15 flight critical LRUs to LCA Tejas aircraft. You may be aware of this. We are actively collaborating right now with the AMCA and SARAS Mark II teams for supply of critical LRUs as well. You all must be aware that our technology center is located at Electronic City, Bangalore. We have approximately 250 employees engaged in design development of commercial aircraft flight control actuation systems. As you also may be aware, we built a world-class qualification test lab. We do assembly and disassembly of the actuation systems to meet our internal design and developmental activities for our own actuation systems. And I just want to mention that we are also AS9100D certified organization. Coming to today's topic, the challenges and opportunities for industry in aircraft programs. As you have seen, my co-panelists have already covered many domains, but I would like to bring your attention to two major areas where Moog is actively engaged, and we would like to partner with the local industry as it deemed fit. The first one is additive manufacturing, a 3D metal printing technology. There has been a lot of research and success being shared by many companies in this field. A few years back, Moog also launched a major initiative to realize the actuation systems through metal printing technology. We are very happy to inform you that we have achieved major success in this domain. We could successfully realize manifolds, actuation systems made out of 3D printing, both steel and aluminum, titanium materials at our additive manufacturing center in USA. And we are in the process of obtaining necessary FAA approvals to bring these products to the mainstream. Once we obtain these necessary clearances, we'll be looking at a business opportunity to partner with the local industry to support customer deliveries. So this is one area where there's a lot of work and there is a lot of interest in the Indian industry as well. Maintenance, repair, and overall, MRO is another area where Moog is planning to spread its wings. All our facilities are across, US and UK, but we have recently started establishing MRO facilities to cater wide-body aircraft like 787 and A350, entire Chapter 27 LRUs in the Middle East and Asia Pacific regions. You'll be surprised to know all the test rigs, test fixtures, test systems for these MRO facilities were actually realized by our technology center through local partnership, and we have exported these to these facilities. And they have been excellent. The wonderful quality has been delivered to them. We are very happy to inform you that our our test rigs are working to the best of the world-class technologies. We are also actively engaged with the regional airlines in establishing MRO facilities here in India as well. We are approaching the Ministry of Civil Aviation through US Aviation Cooperation Program team, and we'll be soon having discussions in establishing repair facility for narrow-body aircraft here in India. We are also actively working a business model how we can have repair facilities for military aircraft programs like LCA. Now that we have the entire 83 aircraft production clearance from the government, I'm sure we'll be looking at an opportunity to enhance that facility of repair and capability here in India itself. These opportunities typically comes with some challenges, especially in the area of skill sets. I'm sure we'll get an opportunity to talk about this, but I just want to bring it to your notice that strict process adherence coupled with attention to the details, that's where the big challenge we are facing in the industry today. So MOOG has revised a structured employee development skill program, and I'll be happy to talk about through this in the next session if time permits. Thank you.
Excellent. Thank you very much, Mohan. Now we go to Manta. Could I request Manta to be the man who has been there a lot of areas?
Thank you, Dr. Kota. Thank you so much. Yeah, like I'm a tail-end batsman. I need to score 20 runs in 1 over. So how much I can score. Thank you so much, SAE, for giving this opportunity of speaking on this conference. It's a prestigious conference SAE conducts year over year. So I think we heard from most of the OEMs, Rolls-Royce, my friend Kishore, Boeing, Moog, and Collins. I give a different flavor, bring a different flavor to this whole event. I represent engineering services company. So obviously we work with many of these OEMs who some of them are there in the panel. And so I represent XPO Group, which is like a 1.2 billion euro company headquartered in Paris. And we have 50,000 plus people across the world operating in 30 different countries. And I had the engineering arm of India for XPO. And for us, aerospace is primarily the main contributor. We have about 40-45% of revenue coming in from aerospace segment. So you can see whom all you work with. Yeah, we have people like Rolls-Royce, Airbus, Dassault Aviation, Collins, now as I said, Raytheon. We work with IAI, Bombardier, you name it. So essentially, we cut across all the OEMs and the major tier ones of aerospace industry. And that gives us a wide exposure to various standards in the aerospace industry, both in software development, like DO178, 254, as well as in the aircraft structures, in terms of the primary, secondary structures, as well as we also work with systems like flight warning system, flight control system, testing all the software which actually flies on any of the avionics LRUs. So now, bringing the context of this specific conference, the topic given to this panel, the challenges and opportunities for Indian space ecosystem, and which way we are actually going to contribute for the Indian aircraft industry. And we all know that India is a fast-growing aerospace hub in the world. We all know it's going to be third aerospace consumer in terms of the passengers. So people are talking about 500 million of Indian population is going to take skies by sometime around by 2025. And on the top of it, because of our geopolitical situation, we have between Navy Air Force, close to about $70 billion worth of purchases still to be made. And obviously, they all will bring in some 30 to 40% of offsets, which obviously need to be fulfilled in India. Now, if you really want me to talk about the major advantages what India has, as we all know, there's a high domestic demand. Today, all the middle class UCR airports, in spite of COVID, you go to a Bangalore airport, you will not find a place to sit. There's so many passengers who are there who wanted to fly. So that's obviously the biggest driver for more and more aeroplanes to be built in India. And then second is the offset policy, as I said. You have a $70 billion worth of money need to be spent, and you have over 40% of that. You can imagine how many billions of dollars need to be actually generated as offsets from India. Obviously, we have a cost advantage in terms of because obviously our wage structures are not so high compared to some of the Western countries. And the talent base, I think India produces close to about 500,000 engineers per year who are English speaking, and you have a highly reasonable intelligence, and they communicate so well across multiple languages. And the fact that in the last 20 years, the amount of industry growth in terms of the aerospace which has taken place in India is phenomenal. When I started career in, say, 80s with the Indian Air Force, there are only two agencies who knows about aeroplane. One is Indian Air Force, the guys who are actually doing the maintenance and are flying, and the second is HAL. So apart from it, nobody knew what is the aerospace is all about. But today, because of so much of aircrafts being flown in India, you see this amount of OEMs and tier ones who have invested and built the engineering centers. I think that's the biggest advantage. And with this Atmanirbhar campaign of the Prime Minister, obviously, in India, I feel that the manufacturing R&D is going to move significantly into India. Apart from the already existing ecosystems of Tatas and Mahindras and Reliances of the world, I feel a lot many more players are going to venture into the manufacturing segment. That in turn will catapult the complete industry, which will obviously becomes like a feeder for many of the aircraft programs which India is embarking on. At the same time, we do also have challenges. Sometimes we really struggle with some access to the technology. If you talk about something like a complex metal matrix composites, etc., or a complex flight control system, as you talked about, developing a control law with a quadruplex fly-by-wire control system, even though we did for LCA, maybe again and again, if you want to do for commercial aeroplane, I think we have a little bit of a gap out there. And obviously, we also have a bit of little fund stop in terms of the amount of investment we make. Obviously, this aerospace is all capital intensive business. How quickly we can ratchet up our revenues and then get a profitable situation where you get a return on investment. There's a bit of a issue out there. And similarly, the certification process in terms of some of the manufacturing industries. We talk about NATCAP. How many of our Indian aerospace tier 2s who are obviously supplying some of the sub-assemblies have NATCAP approvals in, say, complex treatment like heat treatment or healing or any of the surface coatings, etc. Far and few. And then in terms of, from past 20 years, we did a lot of growth in terms of qualifying our engineers and technicians with the aerospace background. Still, the amount of skill gap between a guy who can do a complex, say, wing design, a supercritical aerofoil, or dealing with, as I said, high level of composite structure design, or for that matter, let's say flight control system design, etc. I think there is still some skill gap which is there, which need to be bridged. And obviously, last but not the least, quality. Quality is something we need to ingrain within the DNA of our ecosystem, within our industry. Otherwise, if we don't deliver with quality, people are not going to accept in the aerospace world. There are many programs. Dr. Kota has already enlisted. I don't want to talk about it, but obviously, TAMCA, LCA Mark II, SARAS Mark II, RTA 90 are some of the programs which obviously need a lot of investment. I think government is very keen on that. But at the same time, support from these tier ones and service players like us, plus the other OEMs, if they can partner on some of these programs, like we are extremely upbeat when Rafale deal was signed. We thought that we see the end of the light at the end of the tunnel with the Kaveri program. The Safran is expected to handhold and take that program to a logical conclusion. But I think we still have some distance to cover before Kaveri can start flying with LCA or any other aircraft.
Yeah, I agree with you, Manta. Your comments are very relevant and very important for us. and there are issues, but there are also opportunities, and there are all expertises that have been built over the last 2.5 decades. So I would like to thank you. We have eaten away a lot of our time, what was supposed to be available for further. But I just want some 1 or 2 comments, not more than that. How do we build this skill, and how do we impart training so that the young engineers can get going and are industry ready when they enter the industry? Because this point, can I ask Kishore to just 1 or 2 points, because you have been in a precision industry. Can you just 1 or 2 points? How do we move forward?
At right after is there into the right areas. Internships, I think right internships at the right times. So students can do it during summers. I think that will be the most useful way of getting them industry trained.
Okay. Okay, this is important. But Mohan, could you like to, because you are a person who have been in the game, can you tell us how do we do the skill development and training programs?
So one thing what we have done at MOG is that we have directly gone to the institutes. Like, we have established a lab, hydraulic lab at NIT Suratkal. So we have devised a program such a way that the students will be doing the actual qualification, testing the actuators, and we actually program them. We will give them the lab manuals, like, how to operate the frequency response test and threshold test. So the students are well prepared, what they're expected to do in the company.
That's what you are saying. That is the best way you feel should be done. Okay.
Yeah. Another thing is in Congo College of Engineering, we are establishing another lab.
Yeah, I understand. You're doing a great job there. Good. But you have to give thought to how to expand. Satish, could you, because you are in that game, if you can tell. I thought you three have to talk.
From my perspective, I think, what Venkatramana touched on is really important, right? I think focusing on process, especially when you're developing, software and system design for especially avionics, which is safety critical, process and discipline comes into the picture. So what we do is we have taken a lot of internship and we train them over this process. And once they join our organization, we also take them through a semester.
Of course you do.
Yeah, but I think this part of aerospace and aeronautical background, I would say, I think there are universities, a lot of universities offering that. But I think something like Embry-Riddle University, which is purely focused on aeronautical engineering, aerospace engineering, I think we need to think of universities which can be deemed.
I think it's a major area. I want to all of you to give a thought. Is there any comment from either my friend from Boeing or Mantha on this? Just this point. Just this point.
Sure, sir. Doctor, very good point. I think panelists are telling here. One thing what I've seen in our aviation and aerospace, and this is me being an aircraft engineer myself, the students have become subject is not being taken as by choice; it's becoming subject by chance. And we have seen, especially between the university and they joining a job, there's a lot of gap. What we did 2 years back was we saw this gap, and we have worked with Air India to start an skilling program for aircraft maintenance. We have developed the whole classroom, labs, and everything at the mobile facility in the hangar. Whenever you all are there, please let me know 24 hours in advance. You can look at that.
Oh, good.
Yeah, 1 year program. We have very thorough examination levels and everything else. The first batch passed out successfully, and they got employed when the market was full of engineers and technicians. So that's we are in the second batch right now. Unfortunately, with pandemic, we have to close the classes. But
it's available. It's available. So I would like to thank all the panelists for the excellent presentation and their intensity with which they have been doing their job, and they have been conveying their ideas, and looking forward to things moving in a big way in India as far as the aviation and aerospace is concerned. Thank you very much. Thanks to all the panelists. Very much.
Thank you, Kota sir, and the rest of the panel members. Before we wind up, there are a couple of questions from the audience, I just wanted to put it in front of the panel, sir. You can direct as you deem so, whomever. So there is one question from Ajit Nair. Your view on today's defense news that Tata Advanced Systems is going to build defense aircraft in India, the private Indian company to do so. So you could able to hear the question? Hello? Sir, you are on mute. SAE team probably have to make all the panel members as co-hosts so that they can unmute and speak.
Yes, sir, we'll do it.
Yeah.
So while that is happening, Dr. Ganga,
okay.
check. Maybe we can take one question here.
Yeah, they're able to hear.
Now I have been unmuted, so I can. Ganga Reddy?
Sir, should I repeat the question?
Yeah, that's why.
There is a question from Ajit Nair. Sir, view on this defense news. Tata Advanced Systems is build defense in India. The private Indian producer.
I think it's getting cut. Your question is not too clearly coming out. Okay.
I'll repeat, sir. Your view on today's defense news that Tata Advanced Systems is going to build defense aircraft in India. The private Indian do so.
The news is that Tata Advanced Systems are going to build C295. Is that the question?
Build defense aircraft.
The C295 is a defense aircraft. It is a defense transport aircraft. Yeah, actually, we are also waiting for that to happen. It may, because it will certainly help to enhance the manufacturing capacity of the full aircraft in India. Okay, it is an important thing where in the private sector they are going to become an OEM. I do think that is a major shift in the way the aviation industry is shaping itself in India. It's a major thing, and it will happen. Okay.
Thank you, sir. There is one more question from Ganesh. His question is, as we are discussing about localization and collaboration, how a bearing manufacturing organization can contribute to this development? How can we approach understand requirements?
I just don't know whether other panelists are here or not. I'm not seeing them. But there are two panelists here. One is the Moog one, another is the engine. These are the two major users of bearings. Okay, the engine bearings are very critical. The second, the actuator bearings are also extremely critical. What we can do is I will request Ravi to pose this problem to them offline and then communicate with the question person. Okay, there's no meaning in telling, but I genuinely feel bearings play a major role in these two areas. Very, very major role. Very critical. They have lots of business to do, but high precision bearings are what we are talking about. Okay.
Sure, sir. There's one last question. Looks like it is from a student. That's why I'm repeating this question. How can students who are currently pursuing engineering can build their career in aerospace and defense sector? And what are the areas they can contribute? This is more related to Skill India.
I just now saw Kishore Jayaraman switched on. So there was a question on the bearings, Okay. I thought you are the major user of precision bearings. If there is a good bearing manufacturer in India, he wants to know to what extent he could be, he get the business from a company like you. Okay. Kishore, would you like to address this?
Well, the only way to answer the question is I got to put him in touch with our supply chain team and let him.
Yeah, I thought that is the best way. Okay, thank you very much. Then the other question was how will the students get the entry into the aviation and all? In fact, the panel discussion, the last point was about skill development and training. Okay. In fact, I thought bits and pieces, each industry is doing their job. Hello? In bits, each industry is doing its own thing, but I thought there is a need for consolidation and in a way whereby different segments of requirements are known and the students can choose in which segment they would like to work. Okay, so that the skill development can happen as while they are studying and the training also can take place so that they become industry ready. I thought that is the important point. I would request an organization like SAE India, they should take a lead in putting together what all the requirements and what are the capabilities, what each industry is already doing, what little additional work that needs to be done. A consolidated one, I do think it will be good for industry and good for students. This would be my suggestion. Okay? But opportunities are extraordinary. There is no limit to the opportunities. We are going, India is growing in a big way in both civil and military. So opportunities are many.
Thank you, sir. I think we have already overshot by around 6-7 minutes. We have collected a lot many questions, sir. We'll post it to you and then we'll try to get the answer and give it to the audience. Okay. And then as we conclude this session, that was really wonderful discussion covering various aspects, including our current opportunities in defense and aircraft program, challenges, partnerships, touched upon skill development. That was wonderful. I sincerely thank Dr. Kota sir and rest of the eminent panel members for such a wonderful discussion and deliberation. Thank you once again.
Thank you.
Over to you.
Thank you. Thank you. Thanks a lot, sir. So now we have a short break for 10 minutes. We will reassemble probably around 4:45 because we are running out of time. We want you to quickly come back. By 4:45, we'll start. Thank you.
SAE India is India's leading resource for mobility technology. As an individual member-driven society of mobility practitioners, the ownership of SAE India rests with its members who are individuals from the mobility community, which includes engineers, executives from industry, government officials, academics, and students. SAE India is a strategic alliance partner of SAE International, registered in India as an Indian non-profit engineering and scientific society dedicated to the advancement of the mobility industry in India. We are the most preferred technical body for knowledge dissemination and skill development of mobility professionals, students and faculty. We are a trusted think tank advising policymakers on mobility-related matters. We are a self-sustaining society with more than 10% of mobility professionals as members. We are a nimble and professional organization creating value for mobility engineering community. The Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat.
Audience, welcome back to the session 2. We will start in a minute from now. Okay, are you able to hear me clearly?
Yes, Dr. Ravi, we can hear you clearly.
Okay. Great.
I'm clear, Ravi.
Thank you. Thanks a lot. So welcome back. Thanks a lot for your time for the first session. You have seen the illustrated dignitaries have given their perspective on the various aspects of commercial and fighter aircraft. Now we are on to the next session, more specifically focused on drones and airborne systems. So in this session, we have the special address on advances in digital technologies in aerospace industry. Then we have a keynote address on airborne systems in India, current status and way forward. Then we have a panel discussion, the challenges and opportunities for industry to support Indian drones. Followed by that, we will have the valedictory address and vote of thanks. Welcome to this session. So, similar to the earlier session, Dr. Gangareddy has conducted that session extremely well. Now we are having this track where we have the chair, Mr. Dinesh Manoharan. So Dinesh Manoharan is a passionate aerospace engineer. He brings together more than 10 years of experience in aerospace, including unmanned aircraft systems, aircraft design and structures, AI, and the blockchain. He is technical head at UCAL Aerospace and certified innovation officer. He is on G31, G34 committees of SAE International. He is currently leading the effort on blockchain for UAS and advanced air mobility. He won many awards, including Dr. Richard Greaves Award from SAE International President, who is the SAE International President. Innovation Excellence Award from Indo-Korea Project from Department of Science and Technology, Government of India. Over to you, Dinesh, for conducting this session.
Good afternoon. Welcome to this technical session on drones and airborne systems. It is my honor and privilege to chair the session. I now welcome the special keynote speaker for the session, Mr. Amit Agarwal. Mr. Amit Agarwal is a technical director of ANSYS India and Asian and ANS. He works closely with strategic customers across industry and has leads many crucial champions for ANSYS India, includes one of the customer retention and new emerging products and global champions on customer successful stories and industrial best practice. He has worked closely with key academia, private and government organizations and multinational design center across industry in India. With the BTech aerospace engineer from IIT Bombay, Amit has been with ANSYS for 24 years. Welcome, Mr. Amit Agarwal.
Very good evening to respected speakers, dignitaries, and delegates. My name is Amit Agarwal. I lead the technical team at ANSYS serving our customers across India, ASEAN, and Asia region. On behalf of ANSYS, I would like to thank SAE India Forum for giving this opportunity to speak at this forum on flying out of turbulence, reimagining defense and aerospace industry. In line with the theme, I would like to start with our view of key initiatives and drivers for aerospace and defense, followed by rapidly expanding role of simulation in aerospace and defense. Moving on, if we look at commercial aviation, on one hand, regulations have been forcing noise and emission reduction. On the other hand, competitive pressures have been driving fuel efficiency, lower design, testing, and certification cost. Maintenance, repair, and overhaul have emerged as key source of revenue for aviation, especially gas turbine engines. While safety continues to be paramount, passenger experience has been key differentiator, including state-of-the-art infotainment systems. From space perspective, Indian space program is best example of launch cost reduction. More launches and increasing thrust on commercialization. More international satellites are being launched through Indian space launch vehicles. Similarly, thrust on satellite miniaturization, high altitude pseudo satellites is growing because of weather forecasting, telecommunication, observation, and exploration considerations. From defense perspective, rapid insertion of next generation systems and technologies. Increasing stealth and lethality is key to stay ahead of time. Avoiding obsolescence is key for imported technologies with overseas dependence. It is time to turn to role of simulation. As per the diagram shown, while 30% of the life cycle cost is during the development stage, consisting of ideation, concept design, detailed design, and testing, the 90% of the cost is decided at the end of development stage. Indirectly, this means opportunity for 2/3 of life cycle cost reduction is determined by decisions made during the development. While simulation has been historically used during development phase and has helped in life cycle cost reduction, it is being increasingly adopted in influencing manufacturing, operations, and maintenance through 3D printing and digital tools and many others. Based on a survey by Aberdeen Group across multiple users, simulations has helped in reduction in physical prototypes, reduction in development time, higher overall equipment efficiency, higher raw material utilization, and improvement in cost targets and on product reports. At the same time, I would like to acknowledge that none of this is new to Indian aerospace and defense. We've been working closely with Indian aerospace and defense across past 2 decades, and Indian aerospace and defense has been the core frontier of application of engineering simulation in product design and development. Moving on to some case studies. A defense industry startup, Optisys, applied ANSYS simulation high performance computing 3D printing technology to deliver order of magnitude reductions in size, weight, and development time for a SATCOM integrated array antenna. Entire antenna was printed in one build as a single component. The elimination of interfaces, seams, and discontinuities make it possible for substantial reduction in the length of the RF path. The absence of mounting surfaces and hardware provides further size and weight reductions. While existing antennas in this space average 50 pounds and contain more than 100 components, the Optisys CETA is only 8 pounds and consists of a single component. Another interesting study from SpaceX. ANSYS simulation has enabled various SpaceX engineering departments to collaborate on their designs to move away from single physics and towards systems level modeling. Using this innovative approach across all engineering departments, SpaceX rapidly iterates, designs, and optimizes mass prior to production. Coupling simulations has helped SpaceX to optimize the weight of the vehicle by 10 to 15%, allowing for increased payload capacity, and system simulation has also reduced board development time from 6 to 3 weeks. Moving to another example, Firefly Aerospace has leveraged engineering simulation to design and verify new generation of built-in safety assurance mechanism for our first rocket. It will meet the strictest government standards. By demonstrating that their technology works, simulation is helping them to obtain regulatory approvals and to get to space faster. For example, Firefly's first stage aerospike engine utilizes a cluster of 12 conventional rockets. ANSYS simulation is used to understand the complex 3D flow field that evolves as a fluid from 12 engines merge and to help reduce temperatures by an order. Switching gears to the area of defense. Coming back to home at our beloved IIT Madras, researchers at IIT Madras worked on hypersonic technology demonstrator vehicle a few years back for the Defense Research Lab. Computational fluid dynamics was used as a virtual wind tunnel to optimize the design of scrambled engines up to Mach 6.5. Researchers first evaluated the ability of simulation by validating a scaled-down intake design for which wind tunnel results were available. Then they moved to simulating the full-scale intake of the scramjet. The team used CFD to simulate a full combustion with 5 struts, each containing 22 injectors and 3 gutters for flame stimulation. The best design achieved with simulation was able to load 95% of the combustor with kerosene, and the experimental results matched the simulation predictions in the measured margin of error. Another example of Raytheon. Raytheon leveraged multi-physics simulation capabilities to develop antenna microwave components with higher power levels, higher frequencies while being contained in smaller form factors. The team at Raytheon solved the electromagnetic model at initial temperature, sent the electromagnetic losses to the thermal simulation to determine the impact of losses on temperature, sent the temperature back to the electromagnetic model to calculate losses on the new temperature, continue to iterate until steady state temperatures were reached. After a few more changes to the materials used in the product, simulation showed that the design worked perfectly, and this was confirmed at physical testing. Finally, simulation results helped Raytheon engineers understand how the failure occurred and how they corrected the design to eliminate future failures in airborne material. Moving to a US Air Force example, US Air Force jets were being damaged when the low tow tractor was transporting them around bases and coming to sudden stop. A single failure of this type could cost upward of $1 million. Physical testing of the aircraft was of limited use in determining the cause of the problem because the actual aircraft could not be risked in a test. The Air Force engineering team used ANSYS simulation to determine the cause of the problem and devised simple solution to the multi-million dollar problem. Controlling the hitch gap was determined to be a simple and effective solution, maintaining towing loads below the allowable limit. In another case, replacement of nose landing gear pistons on a Boeing 707 variant was a major expense. US Air Force engineers used simulation for structural and fatigue analysis to identify the new thread repair method, which extends life of these parts. The static strength margin of safety was verified through simulation, and the fatigue life was verified through digital fatigue analysis. Savings are estimated at about 22.3 million in avoidance of new procurement and 1.3 billion in reduction in repair expenses in the first year of implementation. Moving to aviation, Embraer many years back used computational fluid dynamics for introduction of winglets on the Embraer 170 without impact on the program's development schedule or timetable. CFD made it possible to analyze tens of configurations in 1 month, resulting in improved designs, new configurations with more attractive options for a given set of structural and manufacturing constraints. These winglets helped increase weight capacity at takeoff, and in addition, drag at maximum cruise condition was reduced by 4.5% on ERJ 0.45. Carbon Freight, a startup based in Pittsburgh. Reducing cargo weight is important to increasing aircraft fuel efficiency, and decreasing the weight of the cargo pallets can contribute, but pallets must be strong and durable. Using ANSYS simulation to develop composite pallets, Carbon Freight considered complex forces, including loading, stress created by cargo and contact stresses as pallets were lifted. They transported and packed together, tested different material thicknesses and fiber orientations without the time and expense of creating physical prototype. By visually demonstrating how its pallets will perform under everyday stresses and verifying their safe performance over time, engineering simulations helped Carbon Freight progress through regulatory approval process. Finally, they were able to achieve carbon pallets that are 18% lighter than traditional pallets. Also helped save 50% in development time and hundreds and thousands of dollars in physical testing. Moving to gas turbines, Pratt & Whitney has been using simulation as critical component to their efforts in coming up with new class of engine designs. For example, Pratt & Whitney's pure power engine design represents one of the biggest advances in jet engines in the past 50 years. Instead of connecting the fan directly to the low pressure turbine via shaft in conventional engine design, Pratt & Whitney engineers introduced a new reduction gearbox into the drivetrain. In the resulting compact design, the bypass ratio was improved from 5:1 to impressive 12:1, and the low pressure turbine developed more work in fewer stages. That meant fewer airfoils, fewer life-limited parts, and ultimately lower maintenance cost. In real world performance, this means 15% improvement in fuel burn, up to 75% reduction in noise footprint, and annual per plane reduction in carbon emissions over 3,000 metric tons. There are many more examples of successful implementation of engineering simulation in aerospace and defense in India and globally. It's time to turn to key capabilities needed to address growing needs of aerospace and defense. If you look at the pyramid of design and simulation, at the bottom we find the component subsystems which is typically modeled through highly accurate physics, but it takes time. Next, we have system and system of systems based on fast but less accurate planned models. At the top, we have missions. Best solution would be if they were able to communicate with each other. This can be made possible through reduced order models, where component simulation data can be integrated into system level modeling using derived reduced order models, and mission assessment simulation can leverage persistent accuracy of physics-based system data. This has been guiding factor for us at ANSYS, where we provided integrated simulation from microchip to the mission. While detailed high-fidelity multiphysics has been our mainstay for 5 decades, over the last 1 decade, we have rapidly built capabilities in the area of systems and platform analysis. Today, with the addition of AGI, we are able to bring more seamless integration between mission, assessment, simulation, physics-based system data. Here on the right, we can see 3 examples. The first one, the drone threat radar cross-section, the current one on Cube satellite actually installed antenna performance assessment. And the recent one is the hypersonic vehicle thermal signature track. And this is critical at how the heat signature of hypersonic vehicles is being communicated at mission level is very significant, which can be achieved through integrated simulation. Switching gears, what are the other considerations? Accuracy still rules the world. Simulation must accurately capture the interdependent multiphysics behavior of modern complex technology in its operation and be validated against test and measurement, be backed by examples of proven success. At the same time, in today's complex world, it is very rare for one vendor to provide all solutions. Engineering teams face simulation and process data management challenges and challenges of working with heterogeneous multiple tool workflows from multiple vendors. Any deployed simulation capability must be open and interoperable. Similarly, workforce enablement. Enabling workforce with latest technology like AI, ML, software and systems is as important as providing the latest technology itself. We at ANSYS have 50-year history of delivering the most accurate physics-based simulation capabilities available. Our platform capability allows team to manage multiple systems, drive business processes, project management, and integrated simulation, chaining, and optimization, while supporting interoperability with the existing tools ecosystem in-house or from third parties. On workforce enablement, we have invested in Simulation Center of Excellence, delivering a combination of training, technical support, consulting, and professional services to industry. In summary, regardless of short-term challenges, there is growing tremendous potential for growth in aerospace and defense, and simulation has a key role to play. Optimization across systems would require components, system, and missions to speak with each other seamlessly. While accuracy is paramount and non-negotiable, open and collaborative platforms and continuous people enablement hold the key to success. Thanks a lot for listening. Wish you a very successful conference ahead.
Thank you very much, Mr. Amit Agarwal, for this wonderful speech. On behalf of the organizing committee, I would like to thank you for this keynote speech. I now welcome the keynote speaker for the session, Mr. Pawan Kumar Chandana. Pawan Kumar is a co-founder and CEO of Skyroot Aerospace, a national award-winning space startup, developing one of India's first privately built space launch vehicle. He was a scientist at ISRO and one of the few Indians named in Forbes 30 Under 30 Asia 2020. Welcome, Mr. Pawan Kumar.
So first of all, thanks a lot for inviting me to the seminar. I think it's a large honor to speak in front of a light audience. In fact, I am from the space industry, but a very keen observer of airborne systems in India. So I'll be happy to present my perspective on the airborne system development happening within India as a very keen observer. So I am Pawan, founder of Skyroot Aerospace, former scientist at ISRO, an alumni of IIT Kharagpur, and so our company builds rockets, which launch satellites to space. So we are into the space industry, but as I mentioned, pretty avid and enthusiastic learner about the airborne systems and also a keen observer in India. So I'll be happy to share perspective even from key learnings from the space sector as well, which could be applied to the airborne sector. So I'll be sharing brief about the current status of airborne systems development within India and the way forward, the technological targets, opportunity and key challenges, and also the best practices for the upcoming decades. So as we all know, the combat aircraft design and development in India started with Marut. In fact, the engineer Kurt Tank, who started, the German engineer who in fact helped the design, was the chief designer, in India at that point of time. So that is where this all started, and in fact, Dr. APJ Abdul Kalam was also a student of him. So that's where our indigenous aircraft program started with the design of Marut, which has done great service for the country, and also it wanted to achieve Mach 2. But unfortunately, there was some shortage, and then we went on to develop the Tejas series, and Tejas is as we all know, now it's 83 aircrafts order is going to be placed, and it is one of the lightest aircrafts of this category in the world. Very advanced aircraft, very useful for the armed forces, and so we have Tejas Mark 1, Mark 1A, Mark 2. And Mark 2 is a fourth generation fighter aircraft with some fifth generation technologies. And then we have AMCA coming up soon. We're looking forward to it, which has which is majorly a fifth generation fighter aircraft, which also has some capabilities of sixth generation aircraft as well. So, I mean, in fact, we have been doing really good. In fact, we have all the technologies for both the fourth and fifth generation. So, in fact, the need right now is probably the Indian aerospace sector visionaries in the beginning, like APJ Abdul Kalam, they always wanted to build technologies of the future. So right now there are several countries working on the sixth generation fighter jet. And I think it definitely, because as AMCA already includes some sixth generation technology, I think it's the next logical step is going for a complete sixth generation fighter jet technologies, even with more advanced than, few features probably maybe, which can be even more advanced than sixth generation. So that's where we can have longer range, longer payloads and swarm capabilities, especially with the utilization of AI. And also utilization of specific payloads and laser capable of cutting other aircrafts, and ability to carry hypersonic weapons, and also augmented virtual reality display for pilots. And we have there's pictures of a couple of sixth generation aircrafts being developed. One by the United States Air Force, the FX, and the other FCAS by the Europeans. So in fact, the main crux of the sixth generation technology is basically swarm capabilities using artificial intelligence, and it's basically the aircraft, the main aircraft will be far away, and also it's mostly it is done through connected drones, which go along with the aircraft. So this is the future, and it is this is going to make our our capabilities to the next level, especially when it comes to fighter aircrafts on the new battlefield. And also, as we have seen in the previous presentation, also I think we have also with UK collaboration for AMCA's Mark 2. We wanted to have an indigenous engine, which is a very big, bold vision for the country at this point of time. And I think that even in the engine point of view, I think this is something which today we use imported engines, and a lot of efforts have gone into the Kaveri engine, and now I think even in the engine front point of view, even though there's a lot of development is going to take place in the next decade, along with the leading OEMs in the world. So there is definite need for the next generation adaptive cycle engine. In fact, GE is developing this engine. This can increase the range by 35%, loiter time by almost 50%. It uses advanced materials. A lot of 3D printing goes into it. And in fact, they claim that the material, the temperatures which have reached while testing this machine, these engines are extremes they've never seen before, and very high performance, and they can work in both high thrust mode and high efficient mode, so that overall range can be increased, and depending on the utility, depending on the range, depending on the requirement, it can be shifted within various type of modes. And another thing is that we do have like AESA's radars, and the next generation radar also needs to be developed at this point of time to be looked into. At least the initial R&D needs to start. And one of the major types of radar systems being internationally developed is the MFRFS, which is like total to be something like 10,000 times. It can take more data than the existing systems. It has like a lot of battle winning edge, especially because of the data it can have to the pilot, and it's like all digital technology, and it gives an exceptionally clear view of the battle space and for and potential targets. And Leonardo UK is like has already built this system and have already tested it in the lab level, and it is soon going to test it in the airborne demonstration phase as well. So this is something we need to look into, and also like make steps to do in-depth R&D into MFRFS. And that is with respect to the fighter aircrafts. In fact, like we are like one of the world leading countries, I should say. And in fact, a lot of countries want to buy our Tejas aircrafts, and definitely AMCA will be like one of the futuristic, one of the top, combat aircrafts in the world. So as a country, we have done great achievements with respect to military aircrafts. And then next comes the helicopters. The current status, we have seen this HAL, Dhruv, Rudra, which have been very successful platforms, on top of which light combat helicopter have been designed, and light utility helicopter is also being designed both for combat and for utility purposes. And also the upcoming helicopter, which we are all looking forward to, is the IMRH, Indian multi-role helicopter, which will be like about 10-ton capacity. Till now, what we developed in-house is under like 5-ton capacity. So this will have like dual engines, etc., etc. And so that is where like IMRH will be an advanced helicopter which can replace many of the foreign helicopters which we're buying today. And there again in helicopters also like definitely we should always think ahead. And the next generation utility and combat helicopter is being designed by the US and also like in a few advanced countries, and that is where even we should step into derive from scratch, from the fundamentals, design a completely new helicopter which can almost like 2x times speed and 2x times of range of typical similar any kind of helicopters we use today. And one of such advanced helicopters you can see is Defiant X, which is being developed by US Air Force. In contact of US Air Force, is being developed by Sikorsky and Boeing. It is basically to replace the Black Hawk, and it can have like very large speed, high range, better maneuverability, more payload. It has coaxial dual rotors, which have very good maneuverability, and especially where the air is thin, it is very good. It gives very good maneuverability, especially in the Himalayas, which needs to be used. And also like it can be, and also future helicopters can be built on common platforms of various sizes, various tonnage capacities, etc., etc. Common platform, common sensors, avionics, engines, so that it is easier to make a series of helicopters to meet all wide ranges. And also it has the stealth capabilities also to improve, especially when it comes to hiding the from hiding the thermal signature, especially by changing the design in a way you can reduce the thermal signature by distributing the heat in a different way. And when it comes to UAVs, UAVs is the future of battlefield, as we all know. And so we have like Lakshya, which is like the target drones. And then like we have Nishant, 4 of them have been already manufactured. And then like we have Rustam 1, which is a medium vehicle, and also like which is almost like long endurance of like close to 14 hours. And then like we have Rustam 2, which has like close to 24 hours endurance. And DRDO Gatak is being developed right now, which is like the next generation of UAV, which is a combat UAV. Till now, like all Rustam 1, 2, all non-combat UAVs. And Gatak will be the combat UAV, which is set to be rolled out by 2024 and 2025. And also like again the UAVs, the next generation tech is something like going for high altitude long endurance drones. So as we know, Rustam 1 and 2 are like medium altitude long endurance drones. So the next step naturally goes to high altitude drones, which can go like beyond 18 kilometers, and also like has a command range of more than 2,000 kilometers is the natural next step. In fact, China has been, this is one of the Chinese hail drones in the left figure here. And also like, it's more like UAVs also like have a great advantage of being completely autonomous. So there is always a debate whether it can be continuous autonomous or not. The continuous autonomous UAVs also without direct human involvement will be faster, can take very quick decisions without bias. Of course, there are like disadvantages which need to be handled when it comes to complete autonomy, but that is where the future is heading to. That's where like as India we need to work upon, both in high altitude, long endurance drones and also like completely autonomous UAVs. So, and when it comes to civil and utility aircrafts, also we have done like good progress. The Saras, there is new production order coming up for Saras aircrafts, which is 9 to 14 seater, and also Mark 2 of that, which can take like 19 seater, and it is planned to roll out in 2025 or so. And then the 80-seater version, which will be like a competition to ATR today, is also like set to roll out to 2025-26. And all these aircrafts are basically, have like 20 to 30% cheaper than the foreign counterparts, which is like a huge cost saving the country if you're able to achieve that mass production range, which meets the demand. And we have this light trainer aircraft called Hansa, which is being used right now. And also like in 2011, there was a successful flight of NM5, which is a 5-seater debut, which is developed with a private participation with Mahindra Aerospace. And the next generation, when it comes to when it comes to utility and civil aircraft, is nothing but electric vertical takeoff drones. This is the future of urban transport, completely electrical, completely eco-friendly. And in fact, like close to 80 companies in the world are developing it. And in fact, like we being the government and the NAL especially having a lot of capabilities being developed, I think this is something which as India we should work on. In fact, like many of these will start rolling and also start commercial operations, including Uber, is getting into it over the next few years. And as India, we should have our own vehicles developed within the country. And this is the future of urban transportation, especially in a lot of the cities in India where the traffic congestion is so high. Today, this is where the future lies in for urban transportation. And several countries like China, Japan, South Korea are like investing billions of dollars into developing eVTOL technologies. And also the whole idea is to build this technology comparable to short range road transport, like car, bus and train transports. They should be like as close to the cost as possible to them, and this will be a great revolution. And we have the capabilities, which is the next step. I think we should have a program which will create the next generation electric urban transport in India. So there's like plenty of opportunity ahead in various, whether it is military aircrafts or civilian aircrafts or UAVs. So there's plenty of opportunity ahead, especially, through indigenization. There's a lot of content to. And the recent ban, thanks to the government, there's a recent 101 ban on 101 items, which also includes like a lot of LCA systems, short range reconnaissance aircraft, expendable aerial target drones. There's several even jet engines. There's a lot of embargo. I mean, there's a lot of ban involved, which is a great opportunity for the private sector to come forward, and bring solutions to the country. And also there's a lot of plenty of opportunities to create technology consortiums, industry consortiums for a particular target, a lot of JVs with foreign companies, and also build products both for domestic and foreign export markets. So there's a lot of capital in India can be, in fact, like risk capital, which can be put into in building products both for India and for the world. So there's plenty of opportunity for the coming decades for the private sector right now. So these are some of the gaps which I feel like we have within the private sector, which needs to be solved. So one of the major drawback is, in fact, like the lack of design and system architecture capability. In fact, most of that design and system architecture capability lies within the government. Involving industry from early phase of designs, involving in the development should also be part of the development progress of all projects of national importance, especially in the airborne systems, which will accelerate the entire program. And also this requires hand-holding from the beginning from government agencies who are taking up the design activities. And also like risk ability is lacking, private sector is not coming forward to actually invest and build their own products and, actively coming forward to, build the next generation technologies, do deep R&D, etc. And this also needs to be encouraged by the government by actually guaranteeing purchase agreements if a certain requirement of the government is met. Let's say something next radar, or there's some kind of avionic system or any kind of system which the government wants, which is critical for the country, which is under import right now. So this can be, or even the entire aircraft, new next generation aircrafts end to end, a consortium can develop. And the government, if it ensures, guaranteed purchase agreements ahead, even though it's a long journey, everybody, we know that it's a long journey. If such kind of revolutionary measures can take place, such risk capital can be put, large companies and consortiums together can come together, put capital by themselves, build it, and also commercialize it for India, for the world as well. And also lack of skills is, in fact, like we as a company, even at Skyroot, like we find a lot of lack of skill in the aerospace sector in India today, across all categories, especially the design and production, because mostly gravitated in the governments. And that is where we need focused skilling programs and dedicated for airborne systems. In fact, for space, because I come from the space sector, so there is a university dedicated for the space. There is a university called Indian Institute of Space Technology, only dedicated for space sector. Even though there are universities for military and for there can be specific universities for airborne systems per se, or like the existing units, educational units can have like courses and also can be promoted more for larger audience to create that skill within the country. There should be a lot of IP creation coming out of the country over the next coming decades. In fact, to really become Atmanirbhar India. So that is where government has to promote IP creation, especially, and it can be done through hand-holding, co-development programs, grants and financial assistance for producing proof of concepts of critical technologies, etc., etc. And also as a country, there is what we lack is in some of the few things which we have seen from the previous programs is like there are long developmental timeline cycles than expected. It comes because of various reasons, etc. And some ways of reducing that is like attracting private industry, high performing startups and private industries into the loop. Because like generally private industries have less red tape to function, and they'll be typically faster if the benefits are larger and if the commercial benefits are good, and also and a lot of skill is already available in the private sector today, even though it's not sufficient fully. Still, I think that can be reduced by involving a lot of startups and industries into the developmental cycle, and also importing of critical hardware to be reduced as much as possible. In fact, that attempt has already been the top priority of the government. But still, even the future critical technologies, even the next 10 years, 20 years to be identified now, and we should start working today. And then early identification and allotment of resources. In fact, even if you see in my presentation, a lot of focus was in the next generation technologies. Today we have certain capabilities. We have 4th generation capabilities, 5th generation capabilities in aircrafts, etc., etc. But still, today we should start working on even the 6th generation capabilities or even beyond. So that's where we need to identify and also allot resources for next generation technologies so that we are self-sufficient in the next phase of developments for the country. So that is also absolutely required this phase. And so way forward for the next upcoming decades would be government should also look into giving direct developmental orders to industry consortiums. That's how it is done in the US and Europe, where capable consortiums take end-to-end product development and deliver to the best, and then they sell it both within India and outside India. So this kind of thing can be promoted within India, and this will be even better with competition. It also has been seen in various sectors across the world. Whenever there's a competition encouraged between the players, there is a really great output which will come out. And also especially there are even US Air Force and US Army, actually they do a lot of competitions between companies. They say this is a challenge you need to solve. So this, and then a lot of companies come forward, they participate, they spend the money, come to the competition level, and then compete against it, and the best winner gets a grant, or the best winner gets a large contract, etc. So you're promoting competition and all, also reduce the developmental cycles, and also public-private partnerships. Just like the aircrafts can be done, in a complete public, not only manufacturing. I'm talking about even the design, development, even a critical part. For example, even control systems, even everything, even the radar system, everything can be actually done, should be done, with public-private partnerships will make it faster, and also that will be hand-holding and generation of IP within the country, even in the private sector, and also focused R&D. We have very less companies in India which focus on deep R&D. That is what is That's where the OEMs of the world are ruling the world today, and that's the reason why we have to buy like a lot of systems from abroad. So that is something, focused R&D should be encouraged, and a target should be like 100% engineering, at least for the next generation stuff. And so this generation, anyway, all the attempt is being done. We are doing good progress, but the next generation is something which we have in our hands today, and that is where like 100% engineering can be targeted. And as I mentioned before, like promoting skilling in the private sector, the skilling is pretty decent in the government sector per se, especially because almost all the activities focused or gravitated towards that. So promoting skilling in the private sector in building, complex systems, R&D, design, engineering, system architecture, engineering, etc., etc. So in-depth end-to-end system level of understanding and R&D also should be able to, that capability also should be built in the private sector. And also, like as I mentioned, this is also very critical. This has been done and proven effective in various countries, even including the US, is like involving startups into the developmental chain. Startups work on stringent schedules. The developmental cycles are extremely small because it's survival for startups typically. So involving startups in developmental phases of critical systems within India is also a great way forward for the country today. And also government is taking a lot of steps in promoting the startup sector today. And this is also, one utility where this is one way where startups also can contribute to national building, especially by participating in programs of national importance, taking it up as a challenge and delivering systems in the minimum possible time if possible in very small developmental cycle with very innovative ideas. Innovation comes with continuous failures very fast, etc., etc., which startups are used to, and it's survival for them. And it will be a very great achievement if startups are put in loop of future development of critical systems within the country. So with this, I conclude. I think we have a great decades ahead of us for airborne systems. We have a lot of technology capabilities developed, and a lot of data capabilities to be developed, which we should target as one of the world leading countries in the world, and the top 3-4 companies in the world. And some things always we should be number 1, number 2 in the world, which is feasible with great steps taken today. Thank you.
We now welcome you to the panel discussion on challenges and opportunities for industry to support Indian drone programs. I am privileged to welcome the panel chair for the session, Dr. M.K. Batmanathan. Dr. M.K. Batmanathan is an aerospace engineer with more than 35 years of experience in education, applied research, enterprise and creation, management, governance, and policy implementation. He is the CEO of UCall Technologies and Director of Regina Tech India Center for Research and Education. Prior to this, he spent 20 years with the Indian Space Research Organization and Aeronautical Development Agency, Government of India. He was also a CEO of Mahindra Aerospace. Welcome, Dr. M.K. Batmanathan. Now, let me introduce all the panel members for the session. It is my pleasure in welcoming Swati Parshar. Swati Parshar is the Group Director for Electrical Design and Integration Group at Aeronautical Development Establishment, DRDO in Bangalore. Swati completed her Master of Science in Physics from Pune University and joined ADE DRDO. She has 25 years of vast experience in the field of system integration, test system development, and testing of UAV systems. Swati has worked on various classes of UAV systems designed and developed by ADE, namely Lakshya, Nishan, Rustam 1, Tapas, and other UAV systems. I now welcome our next panel members, Dr. Omkar. Dr. Omkar serves as the Chief Research Scientist at the Department of Aerospace Engineering, Indian Institute of Science. His research interest includes uninhabited air vehicles, autonomous navigation of UAVs, helicopter dynamics, satellite image processing, yoga, and biomechanics. Dr. Omkar heads the UAV labs, computational intelligence lab, yoga, and biomechanical labs. He published more than 140 articles in leading international technical journals. He is also the convener of subcommittee on standardization of drones in India under the Bureau of Indian Standards. Our next panel member is Dr. Dhiran Narjadi. Dhiran is the Vice President for Global Business Development, Aerospace and Defense in Alter. Dhiran Narjadi is responsible for accelerating the Alter's business in global aerospace and defense industry. He is responsible for delivering the industry-specific solution to Alter sales team. Dhiran has over 36 years of professional experience, of which over 30 years has been with Alters, where he has held several positions, including those in technical, program management, sales, and business development. Dheeran holds a Bachelor of Technology degrees in Mechanical Engineering from Indian Institute of Technology, Kanpur, and PhD in Mechanical Engineering from University of Missouri. Our next panel member is Mr. Sripati. Mr. Sripati is a technical manager of MSC Software Corporation, Indo-Pacific region. Sripati leads the Aerospace Technical Division. He started his career at Indian Institute of Science as a project engineer, worked on MAV design and analysis and thermal structural analysis of satellite solar panels. Sripati is currently working with MSC Software on aeroelastic, structural dynamics, optimization, generative design, thermomechanical composite, and various integrated simulation solutions for over a decade. He played a key role in providing integrated simulations to indigenous Indian defense projects. Sripati has a notable international publication on aeroelasticity and related technologies. Welcome to all the panel members.
Good evening and welcome to everyone for this session on the challenges and opportunities for industry to support Indian drones. So this panel discussion will primarily evolve around the current opportunities for industry to support Indian programs in drones and airborne systems. Also the support required from government and professional bodies as the standards and various aspects are evolving. We can also dwell on what are the best practices and key learnings from your experience of having used the drone design and development or even otherwise in its applications. And we can cover what industry needs to do in terms of building competency and capability. As you're all aware, we're just a maturing industry in this line, and a lot of us have to learn as we go along. And so this is a very important aspect. So the skills and training that are required for this, be it a drone pilot training, be it the process of how to design and develop drones for various applications, is another area in which it will be very interesting to hear from my panel members. Of course, last but not the least is the current challenges that exist in our marketplace presently and as we go along, as you foresee the market over the next 10 to 15 years. I will be very eagerly looking forward to your presentations, each one of them on your own thing. And at the end of the session, maybe we can have a 10-15 minutes of question and answer session where we could dwell on some of the points and open to the public. Thank you very much. Ms. Swati Parashar to share her experiences on the design and development of drones. As you are all aware, she is from the major Indian industry, which is into design and development of drones, called the Aeronautical Development Agency. I would request her to make her presentation.
Good evening, all of you, and thank you, SAEINDIA, to SAEINDIA to give me an opportunity to be on the panel with all the distinguished members. And as told, I work for AD DRDO, and I have worked for a variety of classes of UAVs. So we have the UAVs for surveillance. We have UAVs as useful for target practicing for the pilots, and we have the UAVs as the target itself. So I am in this field of system integration of UAVs and testing for more than 25 years. So we started with Laksha, Nishant, and Rustam 1 and Rustam 2, which are mainly for surveillance and reconnaissance. And these are all UAVs on a high up side of, say, the class totally on the endurance or the range, or mainly for the our military services, and we are also into. I have also worked for the cruise missile integration, like Nirbhay, and for the high-speed target aircraft itself, which is Abhyas. So as we were earlier onto UAVs, it was mainly for surveillance and gathering information, totally on the video side or on the electronic intelligence on that way. And now recently, we all are aware about the Armenian and Azerbaijan war, in which we had the UAVs on the forefront. So the scope of UAV has totally been transformed, and we are getting into a totally new aspect of it. And even recently on the Army Day during this month, we had the Army demonstrate the Swarm UAV in an offensive mode. So in that, we are seeing that the use of UAVs this has totally changed. And since I'm saying the technology has totally changed and it is all upgrowing, we are seeing that the electronics and the features are going and increasing multiple folds. And miniaturization is happening, and even the testing, I totally am on that field. I am seeing that there is a huge class upgradation on this. So, and our UAVs in India, we are using it from agriculture to event management to everything. But now seeing UAVs totally playing a major role in defense is very challenging and interesting. So a lot of opportunities for new technologies, what we are seeing using AI and ML. We are seeing that they are getting into real war use. So that is what I feel, certainly there is immense opportunity and lot of learning, and scope of drones is just increasing multiple folds than what we anticipate, and it is just far being said. That's my opinion on.
Nice to hear, madam, for all the opportunities that has been done. As the next speaker, I invite Dr. Omkar, who is a research scientist with the Indian Institute of Science, Bangalore, to present his views on the various aspects relating to the drone D&D.
I'll be making a brief presentation about the challenges and opportunities. Today, we are all talking about drones. It has become a ubiquitous word, almost a household word. Everybody understands now what the drone is. Well, I would like to draw your attention to this. You see, we are fighting against the quality and cost. The whole game is revolving around this. So if you look at the 4 quadrants, the top left is the high quality, low cost. Well, it is very desirable that you have very high quality available at very low cost. But the point here is you have to have value. If you don't have numbers, it is very difficult. Right now, the Indian market, we do not have that kind of numbers. That is the difficulty. For example, composites. We are all well versed. There are a lot of labs, a lot of industries who can do. But if you want to make a propeller for a drone using composites, you cannot make it as less cost as it is available in the market just because you don't have value. It is easier to import than to really make one. So we need to have volumes if you want to have high quality at low cost. Otherwise, the only option for this is you have to be a philanthropist, which doesn't really work. So this high quality we want to have at low cost, volume. In fact, most of what you see today in the market, whatever is available cheap, whether it is motors or other electronic stuff that goes with the drone, they're all fairly cheap. And if we have to make one of that quality with that competitive rate, it's going to be difficult. So this is one of the big challenge. We should see how we can get those numbers. That is important. Of course, if you see the bottom lower left corner, low quality, low cost, definitely we all know that nobody wants to be here because it's not going to be sustainable and there are no standards in this. It's all going to be some sort of a jugaad which will work, which is not going to have a long-term benefit, and it cannot become a brand. You cannot build a brand out of these things. So nobody would like to look at this. Then on the other hand, you look at the right hand bottom quadrant, you see the low quality and high cost. Well, if you want to do that, if you want to succeed here with low quality, high cost, you have to be lucky. And many times this is not going to be ethical because you are selling something of low quality with high cost. And these things are going to be very, very temporary. And if you look at the right top corner, if you want to high quality, you need to have high cost. Here, if you want to survive, you should have good standard practices. Setting standards, very important, and maintaining that is important. And you should have some unique selling factor here. Only then people will look at you. This uniqueness, yes, we have the strength here. Although we are not in a position to make hardware as of today at the cost which is competitive with rest of the world, still our uniqueness is in making good analytics for the drones. We are good in our software, and we all know today drone is not just about the hardware that you buy. It is the analytics that go with it. What you do with the video, what do you do with the data that you acquire. Then how do you drive these drones? Because it's not the question of a single drone. There is going to be multiple drones. The traffic management of UAVs, so-called UTM, that all kicks in. And these are these sectors where our country can play a very, very strong role. So this is a quadrant where we can actually right now place ourselves. And once the value builds up, cost will actually come down. Then we can also become competitive in terms of the price. But right now, we need to look at what kind of uniqueness can we bring to this whole gamut of UAV in terms of deciphering the drone data. That is the most important thing. So considering these things, I would like to just make 4 recommendations. One is standardization. This is something very, very, very important. We cannot neglect this. Standardization has to be taken very seriously so that we are aligned with the rest of the world. Otherwise, we will not be able to export in the days to come. I'm sure the drone dynamics are going to change very vast, and opportunities are plenty. If we do not follow standard practices, then we will not be in a good place, because India has lost some of the races. For example, in medical devices, lack of standardization, we have lost the race. But fortunately in drones, we are not that much lagging, and it is high time that standardization is taken seriously, put to practice, so that industry will also get to know what they have to do. When we talk about standardization, we are aware that standardization as of today and standardization for the future is also important, so that the industry will have proper guidelines to carry out their manufacturing and other processes. Second one, If you want to develop more value, you should develop new business cases. The interesting applications need to be brought in, because UAV in India can have tremendous bearing because of the sheer population and the complex structure of the distribution that we have. It can play a tremendous role in almost all aspects of life, right from vegetable supply to some advanced medical supplies and medical organ delivery, etc. So there's a whole gamut of interesting business cases that can be built up. And this has a strong link with standardization, we should remember, because standardization can only bring in better sense of reliability and dependability. And then the business cases will also make sense. So we need to focus on standardization and develop interesting business cases because our strength lies here in when we develop business cases. It is not just that drone with the propeller, motor, electronics, etc., hardware and firmware, but it also what the software does. How are you going to do the software analytics so that things become better and useful? And third one is, of course, develop integrated solutions. This is what we mean by drone analytics. So we are not going to just sell a drone as a piece of equipment, but with it comes whatever the chosen purpose, whatever maybe it is, the underlying software that can also go. The software does not mean that it has to be sitting on board. It can be on a cloud or any other computing platform. For example, if you are using drones for surveillance, which is very popular these days, and you can build a layer where you can identify certain things. For example, violence activity detection. Drones could be flying over crowds. We have been witnessing a lot of things in our country. When drones are flying, that is good. It is sending a lot of video feeds, but one, you cannot expect a human to monitor all these video feeds. If you have an automatic way of identifying the violence activity, and it can geotag the location and alert the concerned law authorities to take proper actions. So this is just one example, and this can be in many other fields. What is important is the analytics should go hand in hand so that you can sell it as a package. That is our strength. Then we have better opportunity to export things and also to develop the internal market. All in all, the value build-up need also be taken into account, and as the value builds up, the cost can come down. Then we should always remember, even while setting the standards, Indian problems need Indian solutions. See, not all the standards that are applicable to elsewhere in the world do apply to the Indian context. For example, in the agriculture, if you look at Australia or America, there are huge farms. Whereas in India, more than 75% of the farmers are small land holders, which means less than 2 acres of land. So we need an Indian solution for Indian problems, even when you are talking of the plant yield estimation, plant disease identification, or pestification, whatever it is. We need to keenly look at the Indian problem and come out with Indian solutions. So all in all, these are the 4 things which I would like to draw the attention of the policymakers, that we need to keenly look at these things, adhere to standardization, develop new business cases, look at drone analytics very seriously, and please remember, Indian problems need Indian solution. I think if we can do these things, we will be at a better pace, and we will not lose out in the race of drones in the international scenario also. Thank you all for giving me the attention.
Thanks, Dr. Omkar. It was an excellent presentation, and we understood the needs of specifically the needs that India has to build. I now invite Dr. Dhiren Marjadi, Vice President of Altair, to make his presentation.
Thank you, Dr. Padmanabhan. And thank you to SAE India for inviting me to this panel discussion. I'm really honored to be part of this group. Today, I'm going to talk about the challenges and opportunities in the industry, especially for drone programs, and how we see this particular industry from Altair's standpoint. So just one slide for Altair's introduction. Our vision is to help our customers drive decisions using convergence of high performance computing, simulation, and artificial intelligence. So at a very high level, the opportunities and challenges in the drone world are that there are a vast number of mission requirements, as the previous speakers have already talked about a few of them. And because of that, there are unique designs for a given set of mission requirements. That leads to a large number of possible drone designs, configurations, etc. You can have rotorcraft drones, of quad rotor shown on the left and the bottom, or fixed wing drone as shown in the middle. But that fixed wing drone in the middle is also a tail sitter. It's not a conventional takeoff and landing kind of drone. Or you can have a tilt rotor drone like shown on the third picture over there. And there are many, many more such configurations possible. And maybe hundreds of them out there. If you look at the drone market, every drone looks different because it has a different mission requirement to meet. So whenever you have this kind of scenario, you need a very fast turnaround of the designs in order to make your drones cost efficient. You cannot spend years designing drones the way we spend designing aircraft. So that's a big difference between the drone design and the commercial or defense aircraft design. Other challenge is, again, is alluded by Dr. Omkar, is that drones are going to be a large number of drones out in the space. They all need to communicate. They all need to work together. They need to follow a flight path. You can't have the FAA or any other aerospace agency guiding every drone or UAV path. So they have to be autonomous or remotely operated, and then that means that you need to do terrain mapping, you need to do flight path management, collision detection, and avoidance. All these are both opportunities and challenges at the same time. So I'm going to talk about the design process that helps us address these challenges that I just mentioned. Many of Altair's customers have started applying this design process, which is based on model-based engineering, model-based design, multiple physics and multi-physics 3D simulations, and engineering data science, which includes artificial intelligence. So the way we look at it is that it's a holistic design process that's MBS driven. So what you see here is a complete system level approach. At the very top, you would take mission requirements at a vehicle level or aircraft level and do a 1D simulation, model-based design to come up with system specifications. Those specifications are then cascaded down to system level and subsystem level. So what I'm showing on the right-hand side is the e-propulsion system. You cascade down the vehicle level specs to e-propulsion specs and further down to system level or subsystem level, like battery and motor, gearbox, propeller, drive system, electronics, etc. And under each subsystem, you have multi-physics and multiple physics solutions, such as computational fluid dynamics, heat transfer, you've got structural, vibration, fatigue analysis, composite design and optimization, electromagnetics, electrothermal. A vast variety of multiple physics and multi-physics solutions are applied to come up with the final design. The idea here is that starting from the vehicle level down to subsystem to component level, everything is driven by model-based system engineering approach. Similarly, on the left-hand side, I've shown structures. Again, you can take the system specifications from the vehicle level analysis and do CFD analysis for vehicle performance, cascaded down to structural analysis for structural optimization and weight reduction, which Altair has been a leader for 30 years. And then you can also do impact analysis. It's a very small picture over there which shows a drone colliding with a stabilizer bar of an aircraft. So again, all those things are highly multi-physics 3D simulation, but you start with 1D simulation and follow the MBSE approach. In the middle, I'm talking about autonomy and flight path monitoring and collision detection and avoidance. Again, there is a lot of different physics that go into that. Electromagnetic simulation for antenna design and placement. Radome design, which is which houses a lot of antennas and its composites. There's a multi-physics solution over there. Terrain mapping and radio frequency analysis and monitoring of the location of the aircraft. All those things are coming into picture. And finally, over here, machine learning algorithms and AI is going to play a critical role in maintaining the autonomy. And those are all integrated solutions, as Dr. Amkar put very rightly, that it's not a standalone solution. Everything has to tie back into the system level specification and system level design that you begin with. So this is one project that Altair worked with Naval Air System Command in the US, where we implemented a model-based system engineering-based design process using Altair tools and third-party tools and Navy tools. And we also designed partially designed a drone that's shown in the picture over here. This is a very quick video of how 1D simulation is done at a system level. All these components are designed as 1D equations. Quickly go through that. You can see all these systems cascading down to component subsystem level. And when everything is done, you can run a very quick simulation to create performance. And then you can run a vast variety or a vast number of simulations with all different parameters to get the performance evaluation. What you see over here is 3 examples of applying structural optimization to the drone design. This is the Maharashtra Institute of Technology. This is a company called Aerostrip that is in South Africa. And this is a drone that Altair designed for Navy's project. And this is the process of topology optimization, which I'm sure most of you are familiar with, so I'll not go into the details over here. This is a video of a drone impacting the stabilizer bar that I had in my slide earlier, a simple picture. It was provided to us by Assure, which is a FAA-funded consortium of universities working on drone safety. And NIAR, National Institute for Aviation Research at Wichita State University, is part of that particular consortium. What you see over here is the flight path of a drone. Over here, we are doing monitoring that remotely using the joysticks. And over here, this person is playing a game by, tracking down those coins, but it could also be very easily converted into collision detection and avoidance and flight path monitoring. Again, very quickly going through all the details of what we have. So finally, coming back to, it has to be a holistic system level integration approach, where you start with system level specifications based on mission requirements and cascade down the requirements to all the designs of systems and subsystems, all based on MBSE-driven and model-based design process. So that's my presentation. I look forward to answering questions on this topic.
Thanks, Kiran, for a comprehensive coverage of drones design and development process. As the next speaker, may I request Mr. Sripati, who is the technical manager at MSC Software, to take us through his presentation.
Good evening, everyone. It's been a pleasure to be a part of this panel alongside of Dr. Omkar sir, who is my guru, and we have Padmanabhan sir, Mr. Dhiren, and Ms. Swati madam. I've been in this domain close to about 15 years, working with various labs and also the global OEMs, and of course I come from a background of some bit of experience with IASC. So I head the aerospace and defense business development for Indo-Pacific, and I'm predominantly a technical person. So I would like to maybe just give an overview of what we and while MSc doesn't need an introduction to a lot of people here, we have tied up with Hexagon now and a little more larger solution providing. So it's been more than 50 years of innovation, and as we stand as one of the original software companies in the world alongside of IBM and Cisco and Microsoft and Apple, we are the only simulation company who are in the league of original software companies in the world. And this goes back to 1962, where computing was not even heard by many people. So this is something which brings us to the next stage of association with NASA, where it all started in 1963 with the Moon mission, and till date, the complex most mass mission or any mission which is involved within India as well is pretty much is on the MSc platform. And when we say Moon to Mars and beyond, the beyond is what exactly we are talking about today. So coming to the challenges of the drone design and as well as the market which is out here, I would like to just give a brief of what is there already elsewhere in the world in terms of what drone scenarios are actually going through. So this is a study from IATA, and there is like a bird's eye view till 2035. Urbanization and the growth of megacities is something which will be on an exponential mode. So it could be Indian cities, or we are talking about Indo-Pacific. This is the region which will need most of the facilities on the urbanization front, which I think has a major impact on the drone requirements, like rightly said by Dr. Omkar sir. So urban air mobility is a catch. While urban air mobility becomes a very challenging activity to provide the solution for the needs, the digital transformation will really help to reduce the time to market. So I'll come to this digital transformation. Do we really do that? A lot of meaning to this. But what are we on the ground level today? That matters a lot than the story. So additive manufacturing again is a wonderful solution today, where all the countries are on the same level. When you look at the conventional manufacturing, India was, of course, in a comparable stage, but not too good to catch up with the European countries. But on the additive manufacturing, we are all on the same platform. We can take examples of some of the best additive manufacturing startups in India, which are world class. And electrification. Not to forget, we are all talking about electrification on a day-to-day basis. It could actually be the impact on the drones. It could be any types of drones. It could be for agriculture, or it could be for medical delivery. Any of these things, the whole electrification will come as a major entity. So once we know all these things, of course, this is the drivers of change across the world for going forward, which is a study which is being published. So what next is that we look as air mobility market. So it could be on the defense front. In fact, when we look at all the defense things are handled by the government entities, which is ADE today. But I think more and more privatization has been pushed in, and then we have Atmanirbhar Abhiyan, which will drive into that. So almost between 60 to 90 towns will look at adopting eVTOLs for various purposes. A market of 35 billion is the the business which can be generated with this kind of a requirement. Of course, this is globally, but in India, it could be even if it is a fraction of it, it is huge. So the first commercial sale across this particular platform, what we are talking about, urban air mobility, is in 2021. So that we are rightly on the point of Jan 27th. We are starting to discuss on this, where Uber, Textron, Airbus, Boeing, they're all playing big in this particular market already in 2021 for commercial business. So 170 major vehicle projects are under development across the globe. So coming to what challenges we have, I mean, like we in the sense, I stand along with the designers, the manufacturers, and there's the inclusive thought that we look at drones as predominantly a quadcopter or a hexacopter or a flapping wing, or it could be any of these designs, not a conventional one going forward. Fixed wing, of course, is one of the ones which has been there. So safety and airworthiness is utmost concern, and you have propulsion efficiency, which comes in a picture. The performance, I think I'll just put this across, and then rotor and rotor interactions between them. The entire totality of design challenges, I think, which Mr. Drain really covered it to a good extent. While we have challenges of certification and standardization. So FAA approved maintenance for few components and all those things are yet to come in picture, but they are not finalized yet. And all the things which are practically connected with controls and mechanisms play a major role in the vehicles what we are talking about. So weight savings, high reliability, controls and mechanisms, noise, of course, and safe is utmost concern. So how do we really get through this in the design phase itself? I mean, like, can we go ahead and test a UAV every time we make a different design change? Every time it goes into a modification, do we test that? So I think that's something which all the companies today are talking about, and there is an ecosystem which is being set. So one is UAM solution, which every company wants to get into today. It could be a startup or it could be a big OEM. There will be small teams because nobody wants to invest so much into a new area where the business is still uncertain and may not get the picture of return to investment immediately. Small teams and mostly confidential. They don't want to release too many documents. They want to reveal only few data about it. And engineers come from aerospace background, of course, but certification and redundant systems and plan, all of these things will be new because UAV has no set certification process yet. And as an entity, we have a solution called as ACTRAN, which is validated from over 15 years in the aircraft OEM turbo machinery tier 1 suppliers, through which we know that there is a consortium already being built, which as I have put as an image in the right hand side, where all the players, which includes, of course, HCL has been involved in these particular things actively from India. And we also have Honeywell, which plays a role big time. And all others, I think you are aware, which also includes, of course, us. So I'll come to the point that where do we come in this. So UAV simulation, I think I'll cut down this to a very minimum because Mr. Dhiren really, went through the details of it. So it could be a complex ornithopter simulation, of course, one of my closest to my heart. So we have done this. This is all-in-all motion coupled CFD, which we have done, and then of course we also have done the FSI, and the whole design can actually be templatized, or we I just put the noise, and then it could be the quadcopter or rotorcraft analysis with its 6 degree of freedom motion, it can be done. And it also goes on with AI and ML as a solution. I will come to the point where we stand in that particular front. So it could be flight physics, airframe structural analysis, manufacturing simulation process, acoustics, which is absolutely our flagship. And we have the short duration event simulation, which could be crash, multi-body dynamics, and nevertheless materials, which we did not really stress in the early stage of design in the past. But materials plays a huge role. It could be composites, it could be advanced alloys, thermoset plastics, all of these things. If we can simulate and then see how we can lightweight the systems, and lightweighting is one part. How do we lightweight it? So with this, MSc as a traditional entity was catering to the needs of simulation alone, which is through design and engineering division of us. And right now we also have got into production machining softwares, CNC simulation softwares, factory automation, that is Industry 4.0, smart manufacturing, and then CMM, that is quality inspection, reverse engineering, and and everything connected to metrology, even including the robots which can actually scan the entire quality inspection for a part. So finally, we would like to build the digital ecosystem in the country, where we can add the value by connecting the data. It could be anything. It could be manufacturing, or it could be simulation, or it could be even the operations, and enable the autonomous operations across. Of course, the manufacturing is the domain expertise which can bring in all of these things together at one point. So I would like to unveil and announce this today to the entire community of aerospace that we have taken an oath to get into the Startup India initiative for our country, and we have set up a Startup India challenge along with Invest India and Startup India. This is the government initiative along with which we have joined. And the themes of challenges are design for manufacturing. You can simulate the reality, additive manufacturing, future mobility. That's what we are talking about. Any company which is a startup can come and actually participate in the contest, and we have a panel which can take care of the selections, and the winner will get all our solutions for free. This is something which is our commitment, so that the startups can grow in India and invest more into this particular kind of R&D, which can lead into a business. And this is our announcement happening today. It's Jan 2021. Applications will take till Feb 21st, Feb 2021, and result date will be July 2021. So that we want to make 2021 more, what do you call it, as challenging for, of course, all the startups, but if they do it, they really get the support from us with our team with this huge experience altogether. So concluding it, I think an emerging and dynamic market in Indo-Pacific is UAM, that is urban air mobility. So UAVs are pretty much a part of that. So India plays a major role. Simulation will play a key role in reducing the development cycle, because everybody wants to make it fast, come with the product, and realize it to the market. Going with what Omkar sir said, certification and standardization is very, very important. And if it can happen with the virtual models and not with the real testing, and then we have standardization or certification based on that, it will help all the companies to reduce the investment on this prototype testing. Maybe they can reduce to only one, rather than looking at doing it with complete destructive method. And not with last the least, Hexagon MSc will support Indian startup companies through our Startup India program, which is announced today, and we can actually take it to everyone. My request with the committee here is to make it more successful for us and get more entries to this, so that all the youngsters see the success through this. So on the right hand side, I would like to also announce this, and of course it's already been unveiled, that Hexagon opens the HexArt Institute, which is the first ever artificial intelligence community center in India. So this is the commitment we have towards the growth of the technology in India, and of course sharing the responsibility to a good extent. This can also provide a lot of support for image processing, or it could be the flight path analysis. All of these things which are connected with ML and AI can be done. So with this, I think I would thank all of you for giving wonderful the share of thoughts, and it's my pleasure to be a part of this particular committee. Thanks a lot.
I would like to thank all the panel members, each one addressing certain specific aspects on the theme of challenges and opportunities for industry to support Indian drone. Maybe we have a couple of questions which I would like to ask. I would like to start with Swati Parashar. As one of the leading Ministry of Defense drone development centers in India, where do you see the technology group in terms of the offerings from Indian industry so that they could gear up the future? Where do you see the need for us? Which are the areas where you believe Indian companies put more of their strengths and then develop things?
Sir, as we are into development of drones, starting from as was projected, like using all the system engineering best practices, using all the model-based simulation studies in the design phase itself, so that we reduce our efforts later on the prototyping and all. So that is one thing, sir, key in all the what is that technologies, what we are using, starting from structures to our electronics to even simulation studies, everywhere, sir, we need the industry to really, we want to hold hands with them. We have started doing that, and we need more participation on that. Even on AI, sir, a new lab has been set up, so we need, even data analytics is one very strong field, what we see.
Thank you, madam. Maybe I would like to ask Dr. Omkar. We are all aware that you are involved with Bureau of Indian Standards for developing standards for the Indian drones. What is the present status, and when can we see the release of these standards for industry so that they could understand, assimilate, and use them?
Yeah, right now I think the version 1.0 is ready. It's a quite complex process. Now BAS is in the process of compiling these things. Then they will be released for 30-day evaluation. Then it will be made public. Then once we have all the comments, we will again sit again, reframe, and then it will officially become version 1.0. I expect it should take about 6 months to have version 1.0.
Thank you. The next question I would ask is to Mr. Dhiren. You have extensively covered the applications in the area of structural analysis and various other advanced things. To what extent computational fluid dynamics and simulations help in the design and development of drones?
Performance computing plays a significant role in the design process. If you remember my slide of Altair's vision, we believe that HPC, simulation, and AI are converging. So when we want to do upfront design, you want to do simulation-driven certification, all those things, you have to run a large number of design studies. Some of these design studies can be computationally very intensive, like CFD and electromagnetics and such simulations, crash impact. Having high-performance computers to do such analysis and running on large number of CPUs or in parallel, so parallelization is also very important. So yes, the design process, simulation process has to be integrated with HPC capabilities.
Thank you. And the last question I would like to have is to Mr. Sripati. Apart from the traditional analysis carried out using MSC software for space, what is the one unique feature that you think is very unique for design and development of drones using your software?
Thank you, sir. I think one is, as I said, light weighting. I think the light weighting is something which we are talking about. So it could be a connected approach of creating a structure which is manufacturable. So manufacturability is something, and it can be with the most less a number of maybe parts making an assembly. So that is something which will drive the development very fast. And as I also mentioned, the machine learning and AI, of course, that is something which really will play a role from the day one of the whole development process. So these are the unique areas where we also have entered, and we would like to work with all the Indian OEMs and startups on these particular areas in a wholehearted way. So that is something which will happen going forward.
Thank you for this session. I would now open it to the audiences to ask a few questions to our panel. Thank you.
Thank you very much, Dr. Padmanabhan and panel member, for a wonderful informative session. Now time for the question and answer. I'm running out of time. We can have one question. The first question: the majority of the drone parts currently being imported. Is there any plan of indigenization of these parts? How the drone supply chain ecosystem need to build in the country? Now,
Can I? Yeah.
Yes, sir. Yes.
Yeah. This, I think, partly I answered in my talk. It's actually a volume game. The technology is available. We are not lagging in the technology. See, any component, if it has to be price competitive, it must be produced in volume. That is the game changer. Right now in our country, because of several things, because we don't have that many business applications, there are some regulations still coming up. So that numbers that the international market has, we still do not have. So once the number builds up, yes, we can definitely be very competitive. This is number one. Number two, we should look at some technologies which are futuristic, where instead of catching up with what is happening in the world, we should take a frog leap approach where we become the pioneers of some new technologies, where again we will become the leaders. And the third most important thing is, yes, we need to build up huge business cases so that the numbers improve, and we should also get into good standardization so that we become acceptable internationally. So this has to be done. There is no other shortcut.
Okay. Thank you, sir. Dr. Ravi.
Yeah, I think we can do one more, but all other questions we can take it offline. I see a lot of questions that have been posted on the chat window. Let us go ahead. One last question. Yeah, thank you.
How are the Indian drones are compiling with the NPNT? That's no permission, no takeoff rules of regulatory authority.
Okay, maybe I could answer this. Yes, you are all aware now the drone standards are evolving, so on the design and analysis and manufacturing aspect. Both DGCA as well as CAI are putting in various conditions and various hardware that need to be built. So there is an Indian developed NPNT which is already in the marketplace, costing around 20 to 40,000 rupees. And once you put that, unless you get the permission from Airport Authority of India, you will not be able to take your flight on. So I think these are all emerging, and more stringent positions will come as we go along.
Thank you, sir. Thank you very much. And I would like to thank the panel chair, Dr. Padmanabhan, and all the panel members for the very informative session on the challenges and opportunities for the industry to support the Indian drone program. Thank you very much again. Over to Aslam.
Yeah, thank you. Thank you so much, Dinesh and Dr. Ravi Kumar. Thank you so much. I definitely enjoyed listening to all the speakers throughout the long session. And they have clearly articulated on we as a country and as aerospace industry can fly out of the current turbulence. And the reimagined Indian aerospace industry in the near future itself has great potential and opportunities, as we learned today. And as one of the speakers said, these are definitely exciting times to be in India in aerospace sector. So with this, I will call upon Mr. Ravi Shankar Mysore to deliver the valedictory address. Let me introduce Ravi Shankar to all participants. Ravi Shankar Mysore has over 32 years of industry experience in engineering in India. He began his career with Larsen Tubro Limited, Mumbai, India in 1988 as an engineer. Prior to joining Heritage Goodrich Corporation, which is now Collins Aerospace, as Director, India Design Center in 2007, he worked for over 9 years at Infosys Technologies Limited as Associate Vice President Engineering Services. He recently served as Vice President Engineering, Global Engineering Center India, Collins Aerospace for 13 years. Under his leadership, the center grew from 100 to 1,400 engineers. And this center has worked in areas of product design, development, sustenance, engineering, and technology development. He is now working as an independent professional since 2020. Ravi has done his bachelor degree in mechanical engineering in 1986 from NIT Surathkal and a master's degree in mechanical engineering in 1988 from IISc Science Bangalore, India. He is a member of SAE India Aerospace Forum since 2015. He is the new incoming chairman of SAE India Aerospace Forum. Over to you, Ravi Shankar.
Thank you, Aslam. Are you able to hear me?
Yes, Ravi, we are able to hear you.
So first of all, thank you so much for giving me the opportunity to propose a valedictory speech for this particular session. Considering the paucity of time, I'll try to be as brief as possible. I guess this whole half a day, seminar is a befitting curtain raiser for the Aero India 2021 that's happening right now. In fact, when we thought about this whole program of Aerocon and the subsequent sessions, I was not at all sure whether we will be able to pull off these sessions. But then I think over the last a few months we have delivered a great Aerocon as well as the subsequent sessions. Coming to the specific event today, I think the topics that were chosen were very good. It really covered a broad range of topics, starting from the defense aircraft programs and the current status and way forward, as well as the commercial aircraft programs and airborne systems and challenges and opportunities in all these areas. The overview provided by Dr. Tessie Thomas, especially on how the government is engaged with MSMEs, various academia institutions, was an extremely informative session. And the presentation by Dr. Girish on LCA was hair-raising in the sense that it is really, so inspiring to see that, LCA has taken really great shape today and is going to be, used by the defense forces and also the new programs that they are coming up with. While our foray into commercial aircraft programs has been relatively much slower compared to what we've been able to achieve in on the defense side, but still I think the presentation by Dr. Jitendra Jadhav was also very impressive, very informative, and all this information is really very, very important and informative to young engineers who are coming into this field at this point in time. Probably when we graduated, 30 years ago, all these programs were not happening, and there was not much activity in aerospace. So today, India is in a very unique position where we have built significant capability over the last 30 years, 20-30 years. Not only that, in addition to the private companies, multinational companies, and government organizations, the role that is being played by engineering service providers or the digital solution providers, be it HCL or Infosys or many other companies, as well as companies like Ansys, Altair, etc., is very impressive. The availability of such software and digital solutions will actually help the whole Indian industry to progress significantly in aerospace development. So I don't want to take much more time on this. So again, I'd like to really thank all the panel members and people and who led the panel discussions. Dr. Padmanabhan, then keynote address by Pawan Kumar, Amit Agarwal, Dr. Kota Harinarayana, Jitendra Jajav, Dr. Girish, and Dr. Tessie Thomas, and the entire group. Before I forget, I really would like to thank Muni for spearheading this whole, Aerocon and subsequent sessions, and the technical committee led by Dr. Ravi Kumar. So I'll now hand over back to you, Aslam. Thank you.
Thank you, Ravi. I will now call upon Mr. K. Venkatraj to give the vote of thanks. Let me introduce Venkatraj to the participants. Mr. K. Venkatraj is Deputy Director General of SAE India, fondly known as Venki. He is an accomplished IT sales and business development professional with over 29 years of experience. He has started his career as a CAD/CAM technical engineer and moved up to PLM sales professional in IIT, TCS, and IBM. During his IBM tenure, he has built a relationship with BlackBerry, Walmart, Astra, South Bhavan Group, Ashok Leyland, HAL, ADA, and other leading automotive, aerospace, and IT giants. Venki has been associated with SAE India as a volunteer for 12 years before moving into SAE India as Deputy Director General in September 2016. In his current role, Venki, as a Deputy Director General, he works with leading mobility organizations in India, both auto and aero, to implement the strategies developed by SAE India Managing Committee, the top decision-making body of the society. He is a proactive leader and planner with expertise in strategic planning, market plan execution, account management, and pre-sales effort with skills in staffing and targeted marketing. Over to you, Venki, for the vote of thanks.
Thank you, Group Captain Aslam, sir. So I think that was a very kind introduction. Ladies and gentlemen, 17th December 2009. That is the day it was born. I mean, Aerospace Forum of SAE India. It was known as Aerospace Board by then, and the person responsible for creating the board, and later he became Senior VP and the President. Thank you, Dr. Bala Bharadwaj. I think we should start with that for all the support you have given. Very recently, he's taken up the position of immediate past President. And it's a very pleasant job starting from December 2009. I think our Aerospace Board, later known as Aerospace Forum, played a very nice role. It has given the aerospace members the PDP, Professional Development Programs, aerospace lectures, and then we picked up the tradition of conducting an Aero Show Eve conference. And then Corona happened. It became virtual. Everything has become virtual. You are aware of that. So ladies and gentlemen, this is the first virtual conference on the Aero Show Eve. My duty to thank a lot of people who have put together this. It is not an independent conference. It is a sequel of Aerocon. I wanted to take a minute to tell you about Aerocon. India always wanted to have a conference which is in the similar lines of Aerotech, which is a premier aero technical conference conducted by SAE International. So we thought about it for over a year, and thanks to Murli Iyer, Muni, and many other senior volunteers, industry patrons who are attending this, this was possible. We have had the AeroCon curtain riser in September, AeroCon in October, and then we had a program with ADAT. This is the last of the sequel programs on the eve of Aero Show. So I wanted to start my vote of thanks, or our vote of thanks, with one organization with 52 laboratories, with 5,000 scientists and 25,000 scientific and technical professionals, our DRDO. Thank you, DRDO, for your contribution to the nation and to Indian aerospace industry. Thank you so much, DRDO. Distinguished Scientist and Director General Aeronautical System, Dr. Mrs. Tessie Thomas, for delivering the inaugural address. Thank you, Madam. It was a wonderful address. And then Program Director ADA, Dr. Girish Shantaram Deodar, for a rich lecture on Tejas and LCA. Thank you, sir. Director NAL, Mrs. Jitendra Jadhav, on commercial aircrafts. Thank you so much. Then came the panel on challenges and opportunities for industry to support Indian aircraft programs. It was very ably chaired by the panel chair, SERB Distinguished Fellow, former Chief Scientist and Program Director LCA, none other than Dr. Kota Harinarayana, a consistent supporter for SAEINDIA Aerospace Board and Aerospace Forum. Thank you, sir. And all the panel members, Mr. K. Jayaraman, President Rolls-Royce, Mr. Tejasvi Narasimhan, Director Sales India, SE Boeing, Mr. Satish Shastri, Director Collins Aerospace, Mr. Manta V, CEO Explio Technologies, Mr. Krishna Mohan, Director Moog India Technical Center. Thank you so much. And then came our friend, Director Technical ANSYS, Mr. Amit Agarwal, for delivering the special address. ANSYS has been a consistent supporter to us. Thank you so much. Co-founder and CEO of Skyroot Aerospace, Mr. Pawan Kumar Chandana. Thank you, sir, for delivering the keynote address on airborne systems in India. Then we had the second panel, again very ably handled by Dr. Padmanabhan, CEO of UCAL. We know Dr. Padmanabhan for several years now. Thank you so much, sir. And the panelists, Ms. Swati Paresha, Group Director ADE, Dr. Sandil Kumar, Professor Anna University, Dr. Omkar, Chief Research Scientist, IISc Bangalore, Mr. Shripadi, Tech Manager, MSc Software, Mr. Dhiren Majadi, VP Altair. Thank you so much. And it's time for us, ladies and gentlemen, if you have been attending our Aero series events, that it's almost become a custom now in SAEINDIA to give the bouquet to a few people, to select individuals who have immensely contributed to the success of the program. We are building this tradition in all the virtual conferences. We will digitally deliver the bouquet and the executive will receive it happily. And may I request the backend team to unmute all the lines so that we can give a round of applause to the individual who receives the bouquet. He is an individual who is relentlessly focusing on aerospace. For him, all Sundays are working days. All working days are Sundays. Someday, we wish to get this kind of energy, the central pillar of SAEINDIA's Aerospace Forum. Any guesses? The technical committee chair of AeroCon, Aero Forum, Dr. G.V.V. Ravikumar. I know you have developed the software to receive the e-bouquet. Thank you so much, sir.
Thank you, sir.
Thank you so much. So it's my duty to you can keep the lines on. I think it's a happy time. We should thank everybody. Another individual who is with a constant smiling face, who is probably not leaving aerospace, but leaving the aerospace board just to chair the engineering education board of SAE India. Very recently has been named as the engineering education board chair, the richest board, I would say. Mr. Jawaji Muniratnam, thank you so much. Our dutiful thanks to all Aerospace Forum volunteers, Mr. Vasant Kani, Mr. Damodaran Subramanian, and many others, and the incoming chair, Mr. Ravi Shankar Mysore, retired VP of Collins Aerospace. Thank you, Ravi. Ladies and gentlemen, I would like to choose a bouquet from the staff category who have put together a lot of things, whether it is 6 in the morning or 6 in the evening or 10 in the evening. I would like to recognize, with your permission, 2 young staff members who have been supporting us all the back-end work. And he is very passionate. I would like to call upon 2 individuals. Both of them are passionate, but one guy is very passionate about the racing and the flights and the cars. And possibly he puts my name everywhere, Mr. Hassan Qasim. Come on, let them see you. And Mr. Yelango, you have to sit down. So both of them share this bouquet. They are welcome here.
Thank you, sir.
Thank you, Yelango, for all the good work. Thank you so much. Kya karenge, sir? Ritual. So this is the best we could do. We cannot offer a tea or dinner or whatever. So I would like to thank one and all, and I would like to thank Vijay Anthony Babu, Vice President of Brand Blitz, who is constantly almost nagging everybody to put things in place. He wanted everything to be perfect up to the last minute. And a very big thank you to the Aerospace Forum members. And we were amazed. The initial curtain riser during the peak Corona period was over 1,500, correct, sir? And then the actual attendance was over 300. Then we moved on to the actual Aerocon. Then the ADAT, about over 100 people. And today we had a peak of 203. So I think you've been our source of energy and positive power in SAE India. We feel extremely good to have customers, volunteers like you. In case if I have not mentioned anybody's name, that is just an oversight. And we thank everybody. We would like to thank all the sponsors who is consistently supporting us. So, ladies and gentlemen, I would like to conclude this session. We thought it was a turbulent flight as far as Aerospace Forum was concerned. A lot of discussion, a lot of doubts, but I think it was a seamless takeoff, and we are on autopilot now. So, very soon, yeah. So very soon we'll see you. You were born with wings. Don't crawl, learn to use them, fly and fly. With that quote of Dr. APJ Abdul Kalam, the man who visualized that India can fly, I guess we are. Thank you. Have a good evening. Have a good weekend. Have a good week ahead. Thank you so much.
Thank you very so much.
Can you play some music? Otherwise, you can continue to share. and then play some nice music. அது இருக்கட்டும்பா.
Vicky, can we disconnect?
Yes, we can.
Hello and welcome to this online performance of the Bar concert series in partnership with De Montfort University. I had a great time studying at De Montfort University. I studied music technology, so I'm very happy to be
Music எதுல play பண்ற? Go to that.
Also grateful to the Bar and the whole team for
இப்போ நான் உனக்கு மெயில் அனுப்பிச்சிருக்கேன். இல்லங்க மியூட்ல தானே இருக்க. வந்துச்சா? ரிஃப்ரெஷ் பண்ணுப்பா. இதை ஷேர் பண்ணு. Stay on mute.
Come and fly away with me. Don't you be afraid, everything will change. You and I, jumping off the edge, seize the dream is never done. So come and fly, come and fly, come and fly away with me. We're rising, we're falling, we're making moves. We're climbing, we're soaring, 1,000 views. We're make it through. We're climbing, we're soaring, 1,000 views. Somewhere by the emerald sea, where the moon and water meet, somewhere close to harmony, when the world is sound asleep. Something's gonna bring the change, journeys we are meant to take. Something at the edge of space, calling us to fly away. Don't you be afraid, everything will change. You and I, jumping off the edge. They say dreamers never die, so come and fly, come and fly, come and fly away with me. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. Come and fly away, come and fly away, come and fly away with me. Come and fly away, come and fly away, come and fly away with me. Something's gonna bring the change, journeys we are meant to take. Something at the edge of space.